About 5 billion years ago, a star much larger than our own went supernova. In its death, it scattered its enriched guts across the universe, creating a cloud of dust and gas light years across. And in certain areas, this cloud of dust and gas clumped together and underwent nuclear fusion, forming the next generation of stars, such as our own. We are formed from the ashes of stars much bigger than our own. We are made of stardust. I'm Damon Scotting, and this is Astronomical. $13.7 billion years ago, there was nothing. And then, the Big Bang. The Big Bang wasn't an explosion as per se. It was the expansion of time and space itself. In the beginning, it was infinitely dense and hot, but it expanded at the speed of light and cooled rapidly. Once temperatures were lower, the first particles burst into existence. They coalesced to form the first atom, hydrogen. For the first 200 million years, the universe was dark, until the very first star was born. This was the start of the stelliferous era, the age of starlight. Stars can come in many different sizes and colours. Depending on their mass, they typically take one of 3 different paths through life. Now, low-mass stars that have less than half the mass of our own Sun are amongst the most common stars in the universe. These are the dwarfs. They can live up to trillions of years and spend most of their time in a stable condition, giving off small amounts of heat and light. When the universe dies, these will be the last stars to go. A red dwarf is the smallest and coolest type of star in the main sequence phase. They're the most common type of star in the universe. Roughly 75% of the stars in our galaxy are red dwarfs. Just because they are small and give off little heat doesn't mean they don't have orbiting planets that are capable of supporting life. This is Proxima Centauri. It's a red dwarf and our nearest star. We recently discovered an exoplanet that orbits the star in just 11.2 days, 32 times quicker than the Earth orbits the Sun. The long lifespan of red dwarfs may make them ideal places for life to exist on. We've already discovered a number of exoplanets in orbit around red dwarfs. But being so close to the star leaves you overly exposed to any solar flares, which are very dangerous to life. Now this is our own Sun. It belongs to the next category of stars. Stars that have a mass between 0.5 to 8 solar masses. They will spend most of their life in the main sequence phase. Before, after 10 billion years, they reach the end of it and swell into what's known as a red giant, burning off the last of the fuel remaining in their cores. Our Sun's lifespan is roughly 10 billion years. As it reaches the end, it will swell to as much as 250 times its size now, before it undergoes the biggest explosion in the universe, a supernova. Supernovas regularly outshine their host galaxy. This is a photo I took of M82, the Cigar Galaxy, before a star within went supernova. A single star in a galaxy containing hundreds of billions of others is able to outshine everything for up to a few days before things start to settle. They produce a shell of ejected matter known as a planetary nebula. These are relatively short-lived, lasting just 10,000 years. What remains at the core is a star now the size of the Earth, but with a mass similar to the Sun. This is a white dwarf. It's very hot and very dense, but they will live for trillions of years, slowly cooling into a black dwarf.
Now this is a super giant. With more than 8 solar masses, these are the biggest stars in the universe. And they all abide by one simple law: live fast, die young. So after a few million years, when all their fuel is spent, these stars will go into a supernova. The large ones will collapse in themselves and form a neutron star, amongst the densest objects in the universe. But then the really large ones, the biggest stars the universe has to offer, will do something even stranger. Now these stars are so massive that they can't stop the gravitational collapse, meaning they form a void in space. These are black holes, amongst the strangest objects the universe has to offer.
Black holes are still today one of science's biggest curiosities. There must be millions of black holes in our galaxy alone that are invisible to the naked eye. For stars that don't quite collapse in on themselves and form a black hole, they produce a huge nebula, a cloud of dust and gas. In certain areas they clump together, condense and form stars. Stars such as our very own Sun. During the early stages of the solar system's formation, things were chaotic. It wasn't until after the first hundreds of millions of years that the debris slowly coalesced to form the 8 planets we know today, some of which are far larger than Earth.
So what is the biggest planet in our solar system? And which one's the smallest? Well, the smallest planet just so happens to also be the closest planet to the Sun, Mercury.
Being the closest planet to the Sun, Mercury feels the full force of its heat. But due to its scarcely thin atmosphere, its nights are well below freezing. It's the smallest of all planets, even smaller than each of the largest moons orbiting Jupiter and Saturn. Mercury completes an orbit around the Sun quicker than any other planet. It takes just 88 days to do so. It's because of this that Mercury is one of the hardest planets for us to see. Due to its tight orbit, it never strays too far from the Sun's glare. Several times a century, you can see Mercury appear to pass across the face of the Sun as it moves in front of our view here on Earth.
Then we have the red planet, Mars, which is about half our diameter.
It is similar in many ways to our own planet, but Mars is a cold, dry world. Home to the biggest volcano in the solar system and one of its deepest canyons. Mars is a place of diversity that has been long suspected to have once harboured life of some form. The dried riverbeds on its surface, along with its polar ice caps and similar seasons to Earth, give us strong evidence that it hasn't always been a desolate wasteland. Mars has 2 moons, Phobos and Deimos. Each are only several kilometres in diameter, and they are believed to be asteroids that were captured by a young Mars's gravity. A day on Mars is just a bit more than 24 hours, whilst its year is 687 Earth days, making it almost twice as long as here on Earth.
Followed by Venus. Venus is Earth's hot sister. It's only about 200 kilometres less in size.
Venus is similar in many ways to the Earth. They are roughly the same size and about the same distance from the Sun. But one thing they don't have in common is that whilst the surface of planet Earth is a lush paradise for life, Venus is a type of hell. Its atmosphere is almost entirely carbon dioxide, and the thick layers of clouds prevent anyone from seeing in or out. On December 15th, 1970, the Russians became the first to land a spacecraft on another planet. It gathered data for 50 minutes before succumbing to Venus's intense temperature and crushing surface pressure. In the early stages of the solar system, Venus may have looked similar to the Earth. However, as the Sun continued to grow, it boiled away the water on its surface and added water vapour to the atmosphere, which led to a runaway greenhouse effect, trapping the heat on Venus. Now the temperatures regularly exceed 400 degrees Celsius. Venus is unique as it's the only planet in the solar system that rotates clockwise. A day on Venus lasts longer than its entire year.
Then we have our planet, planet Earth, about 12,000 kilometers in diameter.
Earth is the largest of the 4 inner rocky planets, and as of right now, it is the only world known to support life. We are a blue planet covered in an abundance of liquid water. An average surface temperature of a mild 15 degrees, as well as a number of other environmental factors, has led to the Earth being filled with life. Regardless of the climate, hot, cold, low, high, life thrives. By far the most unique planet in our solar system.
These are the gas giants, the smallest of which is Neptune. Now Neptune is about 49,000 kilometers in diameter. It's huge.
Neptune is the most distant planet from the Sun. Discovered in 1846, it has only recently completed a single orbit around the Sun, with one orbit taking the equivalent of 165 Earth years. Neptune gets its colour from the methane in its atmosphere. It absorbs the red light from the Sun but reflects the blue. The winds on the planet can reach 1,300 miles per hour, almost twice the speed of sound. And due to the intense pressure on the planet, it can lead to hydrogen and carbon forming diamonds that rain down.
And it's soon followed by Uranus, which is 51,000 kilometers in diameter. Uranus is special because as most planets rotate clockwise, Uranus rotates on its back.
Uranus is a gas giant. A collision with a planet-sized body has knocked it sideways, meaning each side of the planet now faces the Sun for 42 years at a time. It was only discovered by William Herschel in 1781 and named Georgium Sidus, in honour of King George III. However, it was later renamed by astronomers to Uranus, after the god of the skies.
Then we have the jewel of the solar system, Saturn. Now Saturn is about 128,000 kilometers in diameter, but if you account for the rings that go around the planet, it would technically be 250,000 kilometers. But we don't do this since there are actually satellites orbiting the planet. We only count the big bit in the middle. Now if I was to ask you to name a planet in our solar system other than the Earth, the first one that probably comes to mind is Saturn. Saturn is the gem of the solar system. No other planet is quite like it. The other gas giants also have ring systems going around them, but Saturn's are unique and beautiful.
Saturn's rings are made from billions of fragments of ice and rock. The rings extend beyond twice the diameter of Saturn, but on average they have a thickness of just 10 meters.
One of the more interesting things about Saturn is the density of the planet itself. Now all the gas giants are made up of the main gases such as nitrogen and methane, but Saturn is filled mainly with hydrogen and helium. And what this means is it's less dense than water. So if you had a body of water large enough to contain the planet and place Saturn in it, it would float.
Saturn was recently classed as having the most moons in the solar system. As of now, Saturn has 82 moons caught in its orbit, but that's likely to change as we discover even more.
Which then leaves us with the god of the planets, Jupiter. Now Jupiter is about 142,000 kilometers in diameter. which is about 12 times that of Earth. In terms of volume, Jupiter could swallow planet Earth 1,321 times. And you see this great red spot on the surface of this planet. It's a storm that's been raging on for almost 400 years. That could swallow the Earth 3 times whole. Our entire planet would be consumed by this storm 3 times.
If you were to take all of the mass from every other planet in a solar system and add it all up, Jupiter would still weigh 2.5 times more. It has the shortest day in the solar system, as well as 4 of its largest moons. These are the Galilean moons, each of which is a wonder in its own right. It has no solid surface, only an extremely thick atmosphere. If Jupiter had been made up of about 50 times more hydrogen, it's likely it would have become a star. Jupiter is very large, especially when compared to the Earth, but it is nothing when compared to the biggest body in our solar system, the Sun.
So just how big is the Earth compared to the Sun? Well, the Earth's about 12,000 kilometers in diameter, and the Sun is 1.4 million kilometers. That means you could fit about 1.3 million Earths inside just one Sun. So to put that in perspective, say the Earth was about this big, then the Sun would be the size of the London Eye.
The Sun is an enormous ball of hot, luminous gas. At its core, hydrogen atoms are converted into helium, releasing energy in the process that is felt here on Earth. It has existed for 4.6 billion years and will likely survive for another 5 billion. The Sun alone accounts for 99.8% of the entire solar system's mass. On the surface, temperatures are 5,500 degrees, whilst at the core they reach 15 million degrees. Despite the immensity of the Sun, it is just an average sized star. There are plenty out there that are far, far bigger.
Now the Sun has been around for a very long time. 4.6 billion years is tremendous, especially when you compare it to the life of a human. We on average live for 80 years. So talking about something that lasts in the order of billions of years is very hard to comprehend. The age of the universe is 3 times older than our Sun. So, in order to make it easier to understand, this is the cosmic timeline. 13.7 meters representing 13.7 billion years of history, where every meter is a billion years and every centimeter is 10 million. Where do we start? The beginning of time and space itself, the Big Bang. However, it wouldn't be until 200 million years later that the first stars were born, and the universe was no longer in darkness. And it wouldn't be until 11 billion years ago that our own Milky Way galaxy would come into existence. Where are we? We're still not born yet. Our own Sun is a 2nd or 3rd generation star, which means it was formed from the ashes of 1, maybe 2 dead stars. This is the birth of our solar system. Now at this point in time, the universe is 9.2 billion years old, which means for us, relatively, we are very young compared to the age of the universe. In the early stages, things were chaotic. It wouldn't be until a billion years later that the first signs of life would form on our planet. Now there's much debate about how life formed. Some believe it came from an asteroid elsewhere in the galaxy that carried the ingredients for life. Others believe it started at the bottom of the oceans around hydrothermal vents. Regardless, the first real species of animal, the fish, weren't born until just 500 million years ago. 375 million years ago, Tiktaalik became the first creature to leave the oceans and venture onto the land, paving the way forward for for many new species, including the amphibians, reptiles, dinosaurs, mammals, and birds. For the dinosaurs, their dominance was unchallenged and relentless for millions of years. Until 65 million years ago, disaster struck when an asteroid wiped out all of the non-avian dinosaurs, meaning the Earth was now up for grabs to those who were left on it. Amongst them were the mammals. They scurried around at night in fear of the dinosaurs, but now they saw their chance and they took it. They made the Earth their own. But in order to appreciate this small of a point in time, we're going to have to make our timeline bigger. How much bigger? Well, it now needs to be long enough to go around our entire planet.
On our current 13.7 metre timeline, each metre represents 1 billion years. But if we stretch it out so it's long enough to go around our entire planet, then on this new timeline, each metre represents just 342 years.
Now on this scale, we have now and 4,500 years ago. What happened 4,500 years ago? Well, we invented the alphabet, as well as the wheel. Soon after, Buddha was born, followed by Christ, the invention of zero, Muhammad, and then just over 500 years ago, the two sides of the planet became aware of each other as Christopher Columbus sailed the Atlantic. Copernicus told us that we weren't at the centre of our solar system, the sun was. Galileo discovered Jupiter's 4 largest moons. Newton released his Principia of Mathematica. At the start of the 20th century, the Wright brothers developed the first airplane. Ernest Rutherford discovered the atom. Edwin Hubble, the first galaxy. And perhaps most important of all, 50 years ago, man left footprints on another world for the first time. And by no means the last. Now when you scale things back to the previous timeline, showing all 13.7 billion years of the universe's history, we take up a very thin margin of it. In fact, the history of our entire civilization can be represented on this scale by the same thickness as 1/10 of a human hair. It's so small you can't even see it with the naked eye. But for me, the most interesting point in time is not on this timeline. It will be on the next one. The next 1/10 of the thickness of a human hair. Think of how far we've come in the past few thousand years, and just how much further we'll go in the next couple of thousand. Assuming we don't destroy ourselves, we will venture to new worlds. Perhaps in the next few thousand years, we'll answer some of the universe's biggest questions. Is it really 13.7 billion years old? And is this the only universe out there? What an astonishing question, asked by a species that was formed from the ashes of a dead star. I'm Damon Scotting, and this was Astronomical. Which planet has the most moons in our solar system. Now, for a long while, this title was held by Jupiter, but recently Saturn gained a new member of its family. In fact, quite a few new ones. Saturn now has 82 moons, whereas Jupiter has 79. Now, it's likely in the future this will change, as every single year we're discovering new moons around the gas giants, such as Enceladus or Titan. So Saturn may not hold the title of most moons for very long. Drone's low on battery.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
I'm Damon Scotting, and this is Astronomical. Light is the fastest thing in the universe. Nothing can travel faster than the speed of light. It's the cosmic speed limit. In just 1 second, light could travel around the entire globe 7.5 times. And although we may think of it as being instantaneous, it's not. Like all things, it has a finite speed. And it's because of this that everything we see is in the past. I'm Damon Scotting, and this is Astronomical.
I'm here in Shanghai, where one of the world's greatest light shows takes place. A permanent fixture in the Shanghai skyline is the Bund Tower. Roughly 600 meters away from where I'm standing, I am seeing it in the past. Because of the finite speed of light, there is a time delay.
Across the river there, that's the Bund Tower, and that is approximately about 600 meters away from me. Now, the speed of light is 300,000 kilometers per second. So when you do 600 meters divided by the speed of light, which is 300,000 kilometers per second, you get roughly 2 microseconds. That's the time delay between the time it takes for the light to bounce off that tower and reach my eye. So I'm seeing that tower right now as it was 2 microseconds ago. So the effects of light may seem insignificant on Earth, because we deal with such small distances, it's impossible for our brains to comprehend the time delay. But what about when we look towards the skies? What about when we look up at the moon? Now, the moon is 384,000 kilometers away. And because light again travels at 300,000 kilometers per second, we can do the distance to the moon, 384,000 divided by the speed of light, 300,000 kilometers per second, and it gives us 1.26. That's the time delay. And we calculated that when the Apollo astronauts put retroreflectors on the surface of the moon. What that allowed us to do was bounce lasers off those retroreflectors on the moon and then receive them back on Earth. And the times we got were roughly 2.52 seconds, depending on how close the moon was to the Earth, because it changes throughout the year. And 2.52 seconds is 1.26 multiplied by 2. So what you've got is the time it took for the laser to reach the moon and the time it took for it to come back.
Moving even further out away from our planet, we reach the Sun. Now, the Sun is 150 million kilometers away, which means it takes light 8 minutes and 20 seconds to reach us. So if our Sun was to disappear, we wouldn't notice it until 8 minutes and 20 seconds later. Nor would we notice being flung out into space, because we were no longer in orbit around the Sun. So at 8 minutes and 20 seconds, the distance delay is starting to become noticeable. Now, what happens if we look out towards the other stars in our universe? Take our nearest neighbour, Proxima Centauri. It's 4.26 light years away, which means if you're travelling at the speed of light, for 4.26 years, you would then eventually reach it. So if you're travelling as fast as you could possibly go in the universe, you still wouldn't reach our nearest star for 4.25 years. Things get even stranger when we look further out. There's one star in the constellation of Orion that may already be dead.
Do you see that bright red star just here? This is a super red giant. It's called Betelgeuse, meaning shoulder. Now Betelgeuse is about to go supernova. In fact, it may do so anytime from now till about 1 million years or so. It's hard to predict. But the point is, it could go supernova any second. In fact, because Betelgeuse is 430 light years away, there's a fair chance it may have already gone supernova. But the light hasn't had a chance yet to reach us. Which raises the question, are we right now looking at a dead star? Has Betelgeuse already went supernova and the light hasn't had a chance to reach us? Maybe. Betelgeuse may have went supernova 429 years, 364 days, 23 hours, 59 minutes and 45 seconds ago. And if it did, then that means it's about to go supernova now. 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 How cool would it be if I shot a laser at a star and it blew up? It's like a dream. Yeah, anyway, for any time from now to 1 million years or so in the future. So maybe it would... One can dream of blowing up a star with a 10-pound laser. Anyway, we move on. Do you see that faint fuzzy patch of light? That's not a cloud. That is an island. An island containing over 1 trillion stars. That is the Andromeda Galaxy. It's 2.5 million light years away, which means the light from this galaxy has travelled unimpeded through the vacuum of space for 2.5 million years, up until the point it hit the sensor of my camera, and now I've captured it. This is an image 2.5 million years old. The Andromeda Galaxy is the most distant object you can see with the naked eye. Okay, it's just incredible. It's incredible what you can do with just a camera. The Andromeda Galaxy isn't something that comes around once a year or once a decade. It is there 365 days. It doesn't go away. It's not something you have to pay to see. It's just there. When you go out and look up at the night sky, it's a free show. And it's possibly the best show in the world when you can see things like this. Over 1 trillion stars. Maybe there's someone, or maybe there's something orbiting around one of those stars who's looking back at us. This is my image of the Andromeda Galaxy. Now, there are over trillions of stars in this image, which means trillions of solar systems. So the idea that maybe in 2.5 million years' time, there is some other sort of being that's looking back at us and taking a similar image of the Milky Way is just mind-blowing. Or maybe in fact, they did the exact same as what I've done tonight 2.5 million years ago.
It truly is incredible the detail that can be made out with just a simple camera. But with the right tools, even more extraordinary images can be achieved. This is a gigapixel image of the Andromeda Galaxy. It is the highest resolution image ever taken of it. At this level of detail, this ocean of stars can be resolved to reveal trillions of individual points of light. At this scale, every single point of light is an entire solar system, as it looked 2.5 million years ago. Because the galaxy is so far away, it is as though you are travelling back in time to see things as they were.
Time travel might seem like something straight out of science fiction, but it's not. Time travel is real. In fact, you and I can both do it. Everyone can do it. And I'm going to show you how. There's 2 ways to travel in time. The first of which is to move. To have a velocity of any sorts, you are travelling in time relative to an observer. The second is to be near a body of mass. That's it. That's all you gotta do. By being on this planet, near the Earth, on its surface, you are travelling in time. Now it may look confusing, but I promise you it's not. In fact, in the next 60 seconds, you will understand how to travel in time. So, we have 4 variables. T prime, just here, is the time at which the observer, me, experiences time. T is the time at which our target will experience time. They are going to be the one moving. They're going to be the one time traveling. And then down here we have V for velocity, the speed at which they're moving, and C represents the speed of light, which is roughly 300,000 kilometers per second. It's very fast. For me, sat here watching them, I've experienced 1.0000000000000000002 seconds, whilst they've experienced just 1. I really hope that's the right amount. Okay. So as they walk past, every second that goes by, I experience it 20 attoseconds slower than they do. They are traveling forward in time. For them, they've only aged 1 second. For me, I've aged an extra 20 attoseconds. But 20 attoseconds is incredibly small. It's almost insignificant. It's 2 times 10 to the power of minus 17. That's 0.16 zeros 2. But what if they were to move faster? What if they were running? Now the fastest a human can run is just over 10 meters per second. But even then, the time difference that me and they experience is still so small. Now what if I was to take a ride on the bullet train?
Now at these speeds you are moving very fast, but relative to the speed of light, this is almost nothing. In fact, if you were moving at this speed for 1,000,000 years continuously, you'd only experience 2 seconds time difference to a stationary observer.
The faster you move through space, the slower you move through time. The closer you approach to the speed of light, the slower time passes from your perspective. So to really appreciate the time dilation going on here, we're going to need to approach speeds much closer to the speed of light.
The time delay you experience increases exponentially the closer and closer you get to the speed of light, until you do eventually reach the speed of light itself and time stops.
Now this is the equation for time dilation based on your proximity to a body of mass. The closer you are, the slower time moves from your perspective. The larger the mass itself, the more time is dilated from your perspective. And the same applies here on Earth. The closer you are to the center of our planet, the slower time moves. Right now I'm on the surface, but if I was to go up a mountain or even a hill, time would tick faster than it would down here on the surface. And I know it sounds crazy to imagine this, and the numbers themselves are incredibly small, but trust me, even your head is slightly older than your feet because of this time dilation. But for this sort of time dilation, things start to get really interesting when you get near a body of extreme mass. I'm talking about the densest objects in the universe. A black hole. Another way to make time move slower for you is to go somewhere where there's a strong exertion of a gravitational pull. And there's no place in the universe where there's a stronger gravitational pull than around a black hole. In fact, there's a region around a black hole referred to as the event horizon, where the gravitational pull is so strong that not even the fastest thing in the universe, light, can escape its pull. And if you were to reach that point, if you were to reach the event horizon surrounding a black hole, time would literally stop for you. It would be the end of your universe. Time travel into the future is possible, but time as we know it right now only flows in one direction. You can't travel back in time, but you can travel forward.
There is no way to travel back in time, but there is a way to look back into it and see previous events, even events that happened billions of years ago. This is a time machine. A telescope is a time machine. The mirrors inside them are like buckets. They capture light from distant objects. The bigger the mirror, the more light you can capture. There's one telescope that has captured the most distant light we've ever seen. And it's also the most famous. This is the Hubble Space Telescope.
7, 6, 2, 1, and liftoff of Spaceship One. Final visit to enhance the vision of Hubble into the deepest grandeur of our universe.
Houston, land a small hologram with the FCS channel.
Hubble launched 30 years ago, carrying the hope and wonder of our entire species. However, disaster struck just weeks into its mission when the world's most precisely cut mirror was noticed to have a small defect on its surface, just 200 nanometers long. Problems like this weren't planned, but they were prepared for. Hubble was placed in a low Earth orbit, meaning potential repair missions were possible. This is footage from the final mission to service Hubble. In total, Hubble underwent 5 repair missions. It will likely function until 2030 before it slowly falls in its orbit around the planet and burns up in the atmosphere before it can reach the ground. But the images it achieved in its lifetime have changed our entire perspective towards the way we see the universe. Hubble has taken some of the most remarkable images in human history, one of which is significantly more important than any other.
Now this may be the most important image taken in the history of mankind. This is the Hubble Ultra Deep Field. Now the reason this image is special is because the Hubble Space Telescope pointed at an area of the sky that was seemingly blank, nothing inside of it. And what it found after exposing itself for just over 10 days was that there are 10,000 galaxies hidden away in this tiny little area.
What looks to be a tiny blank region in space reveals the true immensity of the scale of the universe. This image takes up an area 1/30 millionth of the sky, but its capabilities are still limited. Einstein showed us a century ago that gravity distorts light, and because of this bending effect it can magnify objects nearby, causing them to appear 10 to 20 times larger than they otherwise would. It's because of a group of several hundred galaxies named Abell 2744 that we are able to see one very special galaxy due to this gravitational lensing. This is GN-Z11, the furthest known galaxy in the universe. It is one of the very first collections of stars to ever form, and it would have looked very similar to this. Hubble has taken us to the very edge. It's allowed us to look back to just 400 million years after the beginning of the universe. But soon, there will be a new space telescope that will allow us to see even further back into time. This is the James Webb Telescope. It is the largest and most advanced space telescope ever made. With it, we hope to see the very first light of the universe. Its precise resolution will allow it to resolve a penny from a distance of 40 kilometers. It was scheduled to launch in 2007 with a budget of $500 million, but due to a number of different factors, the costs of the telescope are now at $9.6 billion, with an expected launch date of March 2021. Its primary mirror is an enormous 6.5 meters, making it far larger than Hubble's at only 2.4. Whereas Hubble made most of its observations in visible light, James Webb is designed for infrared. Infrared observations are far superior when looking for older stars and galaxies, as they penetrate dust and gas clouds far better. Its infrared capabilities are expected to allow it to see the very first galaxies that formed just a few 100 million years after the Big Bang. The James Webb will also be an excellent addition in our search for exoplanets that may harbour life. The telescope's capabilities allow it to analyse the spectroscopy of a star's light that passes through the atmosphere of a planet, telling us its composition and if it is able to harbour life. The mirror is too big to fit inside the spacecraft that will launch it from the surface of the planet, so it needs to be folded. It also features the largest sun shield ever flown. 5 layers the size of a tennis court will protect the telescope from the heat of the Sun, Earth and Moon. One of the biggest reasons Webb is taking so long to launch is because of where it's being placed. Hubble was in a low Earth orbit just 540 kilometers away, whereas Webb will be placed in Lagrange Point 2, 1.5 million kilometers away. L2 is a point in our solar system where bodies experience equal gravitational pulls from the Earth and the Sun, thus moving in a constrained orbit, effectively around the Sun itself at the same speed the Earth does, despite being further away. The telescope will be pointing away from the Earth, Sun and Moon, protected by its sun shield, operating at a cool temperature of minus 220 degrees Celsius. The telescope will be making observations in infrared, so it's key that there is no distortion from anything nearby.
Now the James Webb Telescope has faced many setbacks, but it won't be long now before it does launch. And when it does, it's likely it will prompt questions we never thought to consider before. It will reveal wonders about the universe that we couldn't have possibly imagined without it. The James Webb Telescope is the ultimate representation of all that it means to be human, to be curious, to wonder, to have a relentless desire to know more. And I, for one, cannot wait for what it will show us. I'm Damon Scotting, and this is Astronomical. Was Astronomical. One. Mountains. Oh, hello. Welcome back to Astronomical. To catch you up to speed, blurred. About the planets, we split them up into 2 categories. You have the inner rocky giants. Nah, fuck it. Fuck that one. Okay. 3, 2, 1. Alongside the likes of the Colosseum, Great Pyramids of Giza and Chichen Itza. This is Machu Picchu.
Oh. I'm so hungry. What do you say? Machu Picchu, yeah.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
I'm Damon Scotting, and this is Astronomical. When we look up at the night sky, we can see roughly 6,000 stars with our naked eye. However, this number is just a fraction of the real number of stars in our galaxy alone. The Milky Way is home to 1 trillion stars, and it's just one average sized galaxy in a universe containing 200 billion others. Which means out there are 200 billion trillion stars. So it begs the question, are we alone? I'm Damon Scotting, and this is Astronomical. Now in astronomy, we often use the numbers millions, billions and trillions. But these are huge numbers. We don't use them in everyday lives. Except when Chris buys 4.2 billion apples and Paige needs to borrow 168 million. But even then, that's only on maths tests at high school. So in order to make you understand how truly large the numbers in astronomy are, I'm going to write it out for you. So, in our galaxy alone, there are 1 trillion stars. A lot of stars. How many exactly? Well, that's 1 with 12 zeros after it. 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. That's how many stars there are in the galaxy, the Milky Way galaxy. 1 trillion. 1 with 12 zeros after it.
The number of stars in our galaxy is immense. It isn't possible to simply look up at the night sky and count all the stars. So the total number in our Milky Way galaxy could be anywhere between 100 billion to 1 trillion.
Now that was just the stars in our galaxy alone. And ours is just an average sized galaxy in a universe containing 200 billion. Now that's 2 with 11 zeros after it. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's how many galaxies there are in the universe.
Although a smaller amount, the number of galaxies is far harder to predict. Despite being hundreds of thousands of light years in diameter, most galaxies are invisible to us. They are beyond our current scope. Some are so far away and dim that we don't currently have the necessary tools to see them. The number 200 billion comes from an average based on the Hubble Deep Field. The image represents 1/32 millionth of the night sky, and there were roughly 5,500 galaxies within it that we could see. So 5,500 multiplied by 32 million means there are almost 200 billion galaxies in the observable universe.
So that's 1 trillion stars in the average galaxy. And there's 200 billion galaxies in our observable universe. So that means the total amount of stars in our universe is 2 times 10 to the 23. That's 2 with 23 zeros after it. Okay, so that's 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. That's it. That's how many stars there are in the observable universe. And we're just 1. 1 in 200 billion trillion. And there it goes, washed away in a matter of seconds. And that's all we are. We are just a drop in a vast ocean. We're a grain of sand on an endless beach. We're nothing. On the grand scale of the universe, we are tiny. And there's 2 things you can do about that. Number 1, you can feel scared. You can feel worried by the fact that we may be alone in this great, vast space. And if we're not alone, maybe that's even scarier. Or you can grab it by both hands. You can make the most of the fact that we might be the only life out there. We are precious. We're unique. We are special. And we need to make the most of that.
Now 200 billion trillion stars is an astronomical figure. It is far beyond the comprehension of any human being. The potential for life seems to be limitless. So the question is, where is it?
Now, given the vast amount of stars in our universe, it seems difficult to believe that our planet is the only one capable of supporting life. So how do we discover new worlds that are similar to our own? Well, when we look up at the night sky around different stars, we observe a region known as the Goldilocks zone. This is a point around a star where the temperature isn't too hot and it's not too cold. It's just right. Now, if a planet is too close to its star, liquid water wouldn't last long and would boil away from the surface. That is true for Mercury and recently Venus. In fact, in the early stages of the solar system, just a few hundred millions of years after the birth of our sun, Venus was believed to have once had liquid water on its surface. But back then, the sun was 70% of its size that it is today. So as it grew in size, the water evaporated. And as it did, it added water vapor to the atmosphere, which led to a runaway greenhouse effect on the surface of Venus, which turned it into the hellish world we know today. Then, going out towards the edge of the solar system, we reach Mars. Now, Mars is far too cold for liquid water to exist on its surface. Although it can have temperatures as high as 27 degrees Celsius, on average they're around minus 60 degrees. And we can see from the surface of Mars that there was once riverbeds where water flowed, but now they are dry. Which leaves us with our planet, planet Earth, where the temperatures are just right for liquid water to exist. And indeed, life does thrive here. So now we know where we should be looking around stars for the right kinds of planets that could harbour life. How do we spot them? How do we know which stars have planets? After all, planets don't give off light, they merely reflect it, and stars are incredibly bright. So how do we detect exoplanets? How can we find planets that orbit around other stars? After all, stars are very bright, but the planets that orbit them give off no light whatsoever. So rather than look out for points of light, we look out for the absence of it. By measuring a star's brightness over a long enough period, we notice dips. These dips occur when the planets orbit in the right plane to us here on Earth. And by measuring the intervals at which they occur, we can determine the size of the planet, the distance it is from its star, the length of its year, and most importantly, whether or not it could harbour life.
Given this information, it seems rather easy to determine whether or not there are habitable worlds orbiting a star. This method of discovering exoplanets has proven successful ever since the first detection was made back in 1992. As of the 1st of May 2020, there are 4,260 confirmed exoplanets in over 3,000 systems, with 22% of those systems having more than one planet. We have still only analysed a very small portion of the stars in our own galaxy, but the results so far are extremely promising. So if there really is life out there, why haven't we heard from it?
So now that we know that there's potentially alien life out there nearby in the galaxy, how do we communicate with it? How do we make contact? Our best method is probably through radio waves, which travel at the speed of light through the vacuum of space. But our nearest star, Proxima Centauri, is 4.26 light years away from us. That means even sending a signal as fast as the speed of light, it will still take 4.25 years before it reaches our nearest exoplanet. Assuming it has life and they have the abilities to respond and send another message, we wouldn't know for another 4.25 years. So from the time we sent our initial message saying a simple hello, it'd be 8.5 years before we got a reply back. So it's very hard to communicate over the vastness of space. But what about intelligent civilizations getting into contact with us? Have we ever picked up a signal from another species? Well, On August 15th, 1977, something very strange happened. A man named Jerry Damon picked up an unusual signal using the Ohio Big Ear radio telescope. Now in the 50s, astronomers decided that if an intelligent life form was to communicate with us, they would do so on a very specific frequency, 1420 megahertz. Now this is special because its wavelength is 21 centimeters, which is the same as that of hydrogen, the most abundant element in the universe. So they set aside this frequency, and only they could specifically communicate at this wavelength. They pointed their radio telescopes towards the constellation of Sagittarius, and they listened out. Then, on August 15th, 1977, 2 days after the measurement was taken, Jerry Damon analysed the measurements, and to his bewilderment, he discovered this anomaly. He wrote down 3 letters next to it. This is a wow signal. And it's still today our strongest evidence of communication from alien life. But it was almost 50 years ago, and since then we have pointed far more sensitive telescopes towards the same region of the sky, and we're yet to hear anything back. One of the beautiful things about science is that we don't just take things as a given. In order for things to be considered as true evidence, they must be repeatable. So sadly for now, the wow signal is just a one-off. But one day, we will pick up another one. Maybe from the same region, maybe not. But this is encouragement to keep on listening out.
There's plenty of reason to believe there is life out there in the universe. But the real question is, are they intelligent enough to communicate with us?
So what is the likelihood that we are all alone in the universe? Out of the 200 billion trillion stars there are, we are all there is in terms of intelligent life. There are believed to be more stars in the observable universe than grains of sand across all of the Earth's beaches. So can we really be the only form of intelligent life out there? Well, one man decided to try and answer this question. This is a Drake equation, developed by Dr. Frank Drake, one of the founding fathers of SETI, the search for extraterrestrial intelligence. It determines how many intelligent civilizations there are in our galaxy that we could discover today. And it starts off with the number of stars that are formed every year in our galaxy. The next variable is the number of those stars that have a planet orbiting them. We believe this number to be 100% or very close to it. This is followed by the number of those planets that are capable of developing life. Then the number of those planets that are capable of developing intelligent life, those of which will be able to communicate with us. And then finally, perhaps most importantly, the longevity of those forms of life. How long the civilization will last before wiping itself out. Now this is very hard to determine because we have nothing to base it on. And if we try and base it on ourselves, the number is very low. Because as an intelligent species that's been able to communicate, we have existed for the blink of a cosmic eye. Now this equation is often the topic of hot debate, because all the variables can give a wide variety of answers. A pessimist would say there are no other forms of intelligent life out there in the universe. Whereas an optimist might look at this and determine that civilizations could last in the order of billions of years, in which case there could be trillions of planets in our universe. Trillions of other forms of intelligent life able to communicate with us. A vast network. And if that's the case, the universe is a very exciting place. And it might seem scary that there's lots of different forms of life out there, but it might seem even scarier that there are no forms of life out there, and that we are all alone.
If we are not alone, then the next question is, what would other forms of life appear as?
So what do aliens actually look like? Well, in the movies, they're depicted in a variety of different ways. They often have a large number of legs, arms, eyes, and most importantly of all, a big brain. I've asked people to send in a few of their designs of what they think an alien looks like. And a general trend is that they're usually green people with lots of arms and lots of legs, as well as plenty of eyes and often tentacles. This is a design that my best friend Paige did. And as you can see on her world that is covered in burgers and nugget trees, the species that live on here have a variety of legs and arms. But there's a strong reason to believe that aliens might not be so dissimilar to us as we might think. The reason they stretch our imagination is because we've never seen them before, and we imagine them to be complex beings. But in reality, they need to be the same as us in order to survive. In fact, there's a number of things you will likely need in order to succeed and top your planet's food chain. The first is an exoskeleton protecting the brain, the most important organ. The second is manipulative digits like fingers. These will allow you to hold tools. Binocular vision to judge distance. Between our eyes there is a parallax, so having two or more eyes allows you to tell how far away something is. The number of legs, arms and eyes is also very important, because too many will overload the brain. It will not allow it to focus on other areas. It is likely that if we discover another alien species, they will have more similarities than differences to us. No legs would lead to mobility issues. One leg would lead to balance issues. 2 legs is just about right. The same with 2 arms. And 2 eyes allows you to have binocular vision. So depending on the way you look at it, we might be the bare minimum you need. Or we might be too much. If we were to discover another alien species, then they might look similar to us. But if one was to discover us and venture through interstellar space, then it might be very different. The vacuum of space is a very harsh environment. We wouldn't last more than a couple of minutes in it. But when traveling through it, the spaces between stars is so vast that even traveling as fast as you could possibly go at the speed of light, it will still take you years to reach your nearest star. Which means in order to do so, you need to adapt to your environment. So it's likely that these cosmic voyagers who are visiting our little blue planet will have done so. Now the question, are we alone, is possibly the most profound question you can ask in science today. It is one that has not only puzzled scientists, but possibly every single human being to ever walk the planet. I can guarantee that at least once in your lifetime, you have looked up at the stars and wondered if there was life elsewhere, or if we are in fact all there is. And if you were to answer that question today, based on the evidence we have, then the answer would be a resounding yes. We are all alone. We are yet to find life elsewhere in our solar system, let alone the universe. And it might seem arrogant or maybe even ignorant to assume that we are all there is. But as a species, we are still very young. And we've explored so little. One day, in the future, we may receive another signal like the WOW signal. One day, we may venture to another solar system. One day, we may encounter alien life. And the knowledge we gain from those experiences will shape how mankind goes forward forever. We orbit around an average-sized star, which makes up an average-sized galaxy, which itself might make up a smaller than average-sized universe. It's possible that our universe is a mere drop in a sea of other universes. So I'll let you answer the question. Are we alone? I'm Damon Scotting, and this was Astronomical. our sun die. Now our sun is about 4.5 billion years old, and is likely it will live out its life as a main sequence stars for another 5 billion years, before eventually it swells into what is known as a red giant. Now at this size, it will likely be so large it will engulf Earth in its orbit. But whereas this will be the end of our life on planet Earth, it may be a new beginning for planets and moons further out in the solar system. As it expands, it will likely heat up the most outer planets and moons, and we could potentially see life on places like Titan, Europa, and Enceladus. And wonders lie ahead. And one day the sun will die. Oh, maybe, nope, okay, 3, 2, 1. Oh, it's a massive crowd down there, yo! The smallest of the gas giants. It's okay. It's okay, here. Use it as a marker. Cool, we'll do another take. He's just trying to do his job. He's a good guy.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
I'm Damon Scotting, and this is Astronomical. A mountain 3 times the size of Everest. A storm big enough to engulf our entire planet multiple times. And a moon with more volcanoes than the whole planet itself. These are just a few of the wonders of the solar system. I'm Damon Scotting, and this is Astronomical. Now this one's a mammoth. Okay. If I was to ask you, what's the tallest mountain on Earth? Then you'd probably say Everest. And you'd be right. Everest measures to almost 9 kilometers tall from sea level. But what if I was to ask you, what is the tallest mountain in the solar system? Well, then you could use basic logic to rule out the 4 gas giants, because they can't have mountains, because they have no solid surface and the pressure is far too high for them to venture up, which leaves you with the 4 inner rocky planets: Mercury, Venus, Earth and Mars. Now Mercury's small, bombarded with asteroids constantly, no big mountains. Venus, Earth's hot sister, not so much. Venus has a similar problem to the gas giants, the surface pressure is far too high. Which leaves you with Mars as the only other potential candidate. Now Mars is almost half of Earth's diameter, but that may work as a benefit. Because Mars is a lot smaller, it has a lower surface pressure, allowing things to venture a lot higher from the ground. And indeed, Mars does have the tallest mountain in the solar system. It's called Mount Olympus, and it's 2.5 times taller than Everest. Now, as we know, Everest is the tallest mountain on Earth. It's almost 9 kilometers high, but Mount Olympus is over 21,000 kilometers high. That's 2.5 times larger than Everest. So to put that into perspective for you, if this right here is Everest, then that makes this Mount Olympus.
One of the main differences between the two is that Olympus Mons is a shield volcano, which means it has a very small slope, roughly 5 degrees on average. It's because of this, and Mars' smaller size compared to the Earth, that if you were to stand on the summit of Olympus Mons, you wouldn't even notice you were standing at the top of the solar system's tallest mountain, as its base would extend well beyond the horizon. Its total surface area is slightly more than that of the entire United Kingdom. It is a true wonder of the solar system. Jupiter is the god of the planets. Not only is it the largest in our solar system, it's also home to the biggest storm we've ever seen. This is Jupiter's Great Red Spot. It is an enormous anticyclone which has been allowed to grow to such a size because Jupiter has no landmass, meaning unlike Earth, there's nothing to slow the storm down. Voyager 1 was the first spacecraft to get up close enough to Jupiter to witness the truth about this atmospheric monster. When it was first discovered just over 400 years ago, it was 3 times the size of Earth, a storm big enough to engulf our planet multiple times. But over the past few centuries, the storm has been shrinking and is now only just a bit larger than our planet. We're not sure exactly when it will disappear, but one thing is for certain, that even at its ever shrinking size, Jupiter's Great Red Spot is still a colossal storm that could swallow our entire planet. Perhaps it is temporary, but for now, it truly is a wonder of the solar system.
So when we talk about the solar system and the planets within it, we split them into 2 categories. The inner rocky planets, Mercury, Venus, Earth and Mars, and then the outer gas giants, Jupiter, Saturn, Uranus and Neptune. Now the inner rocky planets are very close to the Sun. In fact, the furthest one is Mars, and even then at any given point it's still within 2 astronomical units of the Sun. So we'll say that bit of seaweed right there, that's the Sun, not to scale. And then the closest one is Mercury, which is soon followed by Venus. Then we have our planet, planet Earth, and then a bit further out we have Mars. These are the 4 inner rocky planets. But then Jupiter doesn't come into play until 3 astronomical units later. So Jupiter is all the way out here. So what lies in this great gap? Is there anything at all, or is it like most of space and completely empty? Well, this is where the asteroid belt lies. Now the asteroid belt is a collection of millions of tiny little pieces of rock, some the size of a particle, others the size of almost 1,000 kilometers. And it stretches all the way around the Sun in one complete orbit. Now if you take all of the asteroids, everything in the asteroid belt itself, and add all its mass up, it still only comes up to half of that of the Earth's moon.
The term asteroid comes from the Greek word asteroides, which means star-like. Even the largest asteroids still can't be resolved through a telescope in the same way a planet can be. Instead, they appear as bright points of light in the sky, like the stars. Within the asteroid belt there are 1.7 million asteroids that are larger than 1 kilometre. But despite there being so many huge rocks, the odds of a collision are less than 1 in a billion. This is because in reality the asteroids are actually really far apart from one another. The asteroid belt is composed of the leftovers from the formation of the solar system when the planets were still coalescing to form the large bodies we know today. There is not enough mass in the entire asteroid belt to form a small terrestrial planet. And even if there were, it still would be very difficult to do so, since Jupiter's gravity prevents the asteroids from forming a much larger body the size of a planet.
So the majority of these are tiny. In fact, the biggest object in it is called Ceres. Now Ceres is a dwarf planet. It's still less than 1,000 kilometers in diameter, which means it's smaller than the moon.
Ceres is the most water-rich body in the inner solar system other than the Earth. We still know very little about the asteroid belt. Some theories about the evolution of life base themselves on the idea that it started here on Earth thanks to an impact from an asteroid that contained the ingredients for life. So perhaps there are still wonders waiting to be discovered within the asteroid belt.
Now Jupiter, as well as being the largest planet in our solar system, also has the most amount of moons. In fact, the current total of moons orbiting Jupiter is 72. However, we're going to look at 4 in particular, Jupiter's Galilean moons. Now these moons were discovered in the 1600s by Galileo himself. They were seen as 4 bright points of light orbiting around the planet at regular intervals. They're known as Ganymede, Io, Callisto and Europa. Ganymede is the largest of these moons, and and it's also the largest moon in the entire solar system. So big, in fact, it's bigger than the planet Mercury.
Ganymede is far larger than our own moon, and in terms of volume, it could fit exactly 12 of the dwarf planet Pluto inside of it. If it wasn't orbiting Jupiter, but instead the Sun at the same distance as any of the inner rocky planets, then it would easily fall under the classification of a planet.
Then we have Io. Now Io is the most volcanic world in our solar system. There are more volcanoes on the surface of Io than there are on the whole of planet Earth.
Io is a hellish world. Upon its surface lie countless scars. It is the innermost of the Galilean moons, which means it is a tortured world. It's in the middle of a tug of war from Jupiter and the other more distant moons. Like most bodies, its orbit is slightly eccentric, which means it's not a perfect circle. Instead, it's more like a squash circle, which leads to points in its orbit where it feels a stronger gravitational pull from Jupiter, and points where it feels less. This causes the moon to contract and expand in a process known as tidal heating. The moon's crust is constantly being broken, leading to cracks appearing and volcanoes forming on its surface. When the first images came in of Io, scientists weren't certain what to expect. In this photo, many assumed that there was another moon behind Io in the distance. But it was only when an engineer pointed out that this was no moon. It was a volcanic plume. The volcanoes on Io's surface were active. Intense lava flows across the surface of Io. A truly bizarre world.
Then we have Europa. Now Europa's surface is frozen, but beneath it lies oceans of liquid. In fact, there's more liquid on the moon Europa than there is on the whole of planet Earth.
Europa is classed as one of our best chances of finding life elsewhere in the solar system. It has a frozen surface, but trapped beneath it there are oceans of liquid water, more than on the whole of Earth. Europa has an even more eccentric orbit than Io. The constant stretching and relaxing of the moon causes geysers to erupt from the surface, firing ice particles high up into the atmosphere.
And then lastly we have Callisto, the second largest of the Galilean moons, mostly featureless.
Callisto is almost the exact same size as the planet Mercury, but it only has 1/3 of the mass. It is the most distant of the Galilean moons, and its heavily cratered surface is one of the oldest landscapes in the solar system. The Galilean moons are each more different than the last. They collectively have a vast number of curiosities that have left scientists very eager to explore these wonders in more detail. Saturn's rings are in their own right a wonder of the solar system. They are made up of billions of fragments of ice and rock, which encircle Saturn with an enormous diameter of 280,000 kilometers, more than twice the planet's diameter. But even more astonishing is their thickness, on average, is just 10 meters. However, the real wonder isn't one of Saturn's rings. It's what lies buried in Saturn's most outer ring. In recent decades, discoveries about this wonder have made it the most intriguing world in the entire solar system. This is Enceladus. Enceladus is a fresh moon. It is only 500 kilometers in diameter, but is the most reflective body in our solar system, reflecting 90% of the light. Beneath the surface of ice lies oceans of liquid. At the bottom of these oceans are hydrothermal vents. The temperature difference between the cold surface and the warm core causes cracks to appear and geysers form. hot jets of ice erupt from the moon's surface. Now on Earth we also have geysers, but here they only erupt to heights of 20 meters. On Enceladus, where the surface gravity is far less, the plumes of ice reach heights of 1,000 kilometers. Most of the ice particles escape the moon's gravity, whilst any that don't fall back onto the moon and resurface it, making Enceladus fresh and reflective. As the moon orbits around Saturn, it leaves a trail of ice, forming Saturn's E-ring. Life on Earth is currently believed to have started at the bottom of the oceans from hydrothermal vents. They produce the ingredients and environment necessary for life. So beneath Enceladus's fresh, frozen surface, there may be life. It could be truly alien life, species that we've never seen anything like, or simple life, single-celled organisms. For decades we've seen Mars as our best chance of life elsewhere in the solar system. But the truth is, life may be found first beneath the surface of a moon orbiting a gas giant. This is Saturn's largest moon, Titan. It is a hazy world with a thick blue atmosphere, making it very similar to the Earth, meaning it has a strong potential for life. But it's very hard to see what the surface of Titan looks like. So in 2005, we sent the Huygens probe to land on the moon and reveal its secrets. Hidden beneath a dense haze lies a solid surface. At temperatures of minus 179 degrees Celsius, most of it is frozen, but not all of it. The Cassini probe orbiting around the moon detected lakes on the moon's surface. But the temperature is far too cold for liquid water to exist, so what is it? This is real footage from when the Huygens probe landed on the surface of Titan. In doing so, it became the most distant probe to ever attempt a landing on another world. Once the Huygens probe reached the surface, it saw rocks that had been eroded in the same way rocks here on Earth are by bodies of water. The lakes on Titan are filled with liquid methane. There is potential for life to exist within the lakes of liquid methane on Titan, in the same way that organisms here on Earth live in water. It is possible that as the sun swells in its later stages of life, and it begins to heat the rest of the solar system, temperatures on Titan could reach levels that would allow liquid water to exist on its surface. The period in which this may happen could be several 100 million years, meaning there is plenty of time for life to form. Maybe, if we can manipulate the atmosphere to make it similar enough to here on Earth, it could become a potential second home once our planet is no longer habitable. This is the most distant man-made object ever. The Voyager 1 spacecraft was launched September 1977, just 16 days after its twin, Voyager 2. Their goal was to take advantage of a rare planetary alignment between the gas giants. Voyager 2 would take a slightly different trajectory in order to visit all four of the gas giants, whereas Voyager 1 was only heading for Jupiter and Saturn before the next part of its mission began. They each carried one of mankind's greatest ever collections. This is the Golden Record. On it are a number of images, songs and other sounds from here on Earth. The record also has a set of instructions that will only be understood by intelligent life. Directions on how to play the record, where the record came from, and what the first image on it should look like. The music and sounds are from all across our planet, It features greetings from the people of Earth in 55 different languages.
Hola y saludos a todos.
Tanti auguri e saluti.
我多孙的小木。
有空请到这儿来玩。
Здравствуйте, приветствую вас.
Bonjour tout le monde.
Konnichiwa.
Hello from the children of planet Earth.
Voyager gave us images of the planets that we could never have achieved here on Earth. It then set off towards Saturn. Imaging the planet, its rings, and several of its moons, including the blue atmosphere of the hazy giant, Titan. For Voyager 1, this was the end of its mission to explore the gas giants, but its final mission had just begun. After gaining speed from its orbit around Saturn, it set off into the very edge of the solar system, heading where no probe had ever been before. But before it begins shutting each of its systems down one by one, Voyager was instructed to do one last task: to turn back towards the solar system and take a final image. It produced arguably one of the most powerful photos in the history of mankind. This is the pale blue dot. It may look insignificant, but this faint, fragile point of light is our home. On it is every single human being to ever live. The entirety of our delicate species have all coexisted for only a few cosmic seconds on this pale blue dot. We may be alone in the universe. There may not be any other worlds out there that are capable of supporting life quite like our own, making this speck of dust, suspended in a sunbeam, the most precious thing in our universe. These spacecraft have only pure intentions: to inform others of our desire to explore in our quest for knowledge. Voyager won't find intelligent life. It will need to be found by intelligent life. As it leaves our solar system and sets off into interstellar space, it is alone, adrift in the vast cosmic sea, carrying the hopes and dreams of our entire civilization.
By 2025, Voyager will have run out of power. But the record on board will likely last 10 billion years. It will outlive our entire solar system. So if we don't manage to make it off our planet, if our civilization doesn't colonize another world, and we are doomed to die in our solar system and never visit other stars, then at least we have this. At least we have evidence of what we once were. There's a popular theory that the reason we haven't seen other alien civilizations is because civilizations themselves don't exist long enough to interact with one another. And if that's the case and we are doomed to destroy ourselves, then there's still hope. There's still hope that one day an alien civilization will come across Voyager and they'll see all the records of what we once were. And for me, that is why Voyager was the wonder of our solar system. I'm Damon Scotting, and this was Astronomical.
As the Secretary General of the United Nations, an organization of 147 member states who represent almost all of the human inhabitants of the planet Earth, I send greetings on behalf of the people of our planet.
Hello from the children of planet Earth.
Now, on Mars, I am
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
I'm Damon Scotting, and this is Astronomical. When you look up at a night sky, it's easy to get lost in the beauty of the stars. But they are just a taste of the endless marvels out there in the cosmos. Invisible to the naked eye, there are things you won't believe. Places where truth really is stranger than the strangest fiction. Out there are immense clusters of stars. Stellar nurseries from when stars are born. Supernova remnants from when stars die. Black holes and other curiosities that have puzzled scientists for centuries and still do today. These are just a few of the wonders of our universe. I'm Damon Scotting, and this is Astronomical. Do you see that right there? That is the Orion Nebula. That is the reason I got into astronomy. That is one of the main reasons that I'm here today. Because when I bought my 4-inch telescope after passing my GCSEs, the first thing I found in the sky after the moon was that. And when I saw it through the telescope, it appeared grey. A few tiny stars inside of it, but I could make out structure. I could see it was a cloud of dust and gas. And then when I read about it and heard it was a stellar nursery, and that's where stars are born, that sticks with you, captivates you, it moves you. And that's why I've been hooked on astronomy ever since. Because of that, right there. And you know what, it's been under my nose this entire time. Every time we look at the constellation of Orion, we look straight at the belt, just here. But the real wonder is just below the belt in its sword. The Great Orion Nebula is one of the wonders of our universe.
It is here, deep within the clouds of dust and gas that can stretch for hundreds of light years, that stars are born. Big, small, red, blue, all stars are birthed in the same way. When certain areas of these colossal clouds condense and coalesce, nuclear fusion occurs as the lighter elements are fused into heavier ones. This is the process in which stars generate their energy. These are 3 different images that I captured of one of our nearest stellar nurseries, the Orion Nebula. At the core, visible through the aid of a telescope, is the centre for stellar birth. Stellar nurseries are arguably one of the most beautiful sights in astronomy. Think of all the countless solar systems that are being born right here. Stars rarely form on their own, however. It is far more common for them to form as a group of stars, known as a star cluster.
Okay, it should be about that. Yes, okay, alright, so there it is. There we go. So this is the Great Globular Cluster in Hercules. is a collection of several 100,000 stars that are very densely packed together. In fact, the diameter of this cluster is just 145 light years. To put into perspective for you, if you compare this to the Sun's neighbourhood, then these stars are 100 times more densely packed together. They are so close to one another that they often collide and produce new stars.
Star clusters are extremely large groups of stars. They typically come in two forms, either a globular cluster, where the stars are packed together in very tight groups of hundreds to millions of very old stars, or open clusters, which are a lot less densely packed together, containing a few hundred, which are very young. This is a Pleiades star cluster, also referred to as the Seven Sisters. It's one of the brightest open clusters in our night sky and easily visible to the naked eye. Here's a picture I took of comet pan-stars passing by the Pleiades. This is a live shot of Caldwell 14, a double cluster. It's another cluster that's easily visible to the naked eye and all the more remarkable when viewed through a pair of binoculars or a small telescope. Open clusters are rarely older than 50 million years, as they are often pulled apart easily due to their loose gravitational bounding, whilst globular clusters are typically 10 billion years old, and were amongst the very first stars to form in the universe. They are all the same age, and as a cluster they orbit on the outskirts of galaxies, meaning they remain tightly bound, uninfluenced by other bodies. Globular clusters are truly a wonderful sight once viewed through the telescope, whilst open clusters are the naked eye gems of the night sky. Regardless of which you prefer, star clusters are a wonder of the universe. Out there, lurking in the darkness of the universe, there are monsters. These wonders of the universe don't obey the rules of physics. The very laws that govern the universe we exist in break down the closer you get to them. They feast on everything. Nothing is spared, not even stars. This is a black hole.
This is a gravitational well. This shows how space is warped by matter. Now in this example we're going to say this is a black hole, and these are stars. Now black holes are incredibly dense and take up small regions in space, but they have a mass equivalent to millions or even billions of stars. So as you can tell, the black hole is warping space, and this is an object of relatively insignificant mass compared to the black hole. So although a star will have its own distortion of space, similar to this right here, compared on a grand scale, it seems almost invisible. So when we put a star near a black hole, it begins to orbit as it falls into the center, where the gravitational pull is so strong that nothing, not even light, can escape its pull. This is known as the event horizon, and what goes in never comes back out.
Black holes form when high-mass stars reach the end of their lives and collapse under their own gravity. They really are the most bizarre things in the universe. They are places where truth really is stranger than the strangest fiction. Looking at it, what you're really seeing is the event horizon. The region around a black hole where the gravitational pull is so strong that nothing, not even the fastest thing in the universe, light, can escape its grasp. It truly is the point of no return. But what lies at the centre of a black hole? Many people have different theories about it, but right now we believe there is a single infinitely dense point of mass in space, known as a singularity. We may never know for sure, as there is no way to witness a naked singularity, to cross the event horizon and see beyond, and then return is restricted by the laws of physics. Recently, however, we obtained our first ever true image of a black hole, confirming many of the theories we had. The orange region around the black hole is the accretion disk, formed when stars pass too close and are ripped apart before being swallowed. This is a representation of how a black hole looks from different angles. They distort space-time and bend light. In our galaxy, there are millions and millions of black holes, invisible, with nothing to light them up. One of the ways we can see these black holes is by observing their gravitational influence, noting any stars caught in orbit around them. Black holes will be the last thing left in the universe.
Now, the idea of two suns setting below the horizon might seem like something straight out of science fiction, but it's actually more common than you may think. In fact, recent evidence suggests that multiple star systems, where two or more stars orbit one another, are more common than singular star systems like our Sun, which are all alone. So if you were sat upon a planet orbiting a binary star system, then sunsets like this would be a regular occurrence. On Earth, our temperature is mainly determined by our axial tilt. Assuming you're not on the equator, then the amount of sunlight you receive during the year varies dramatically, and so do the temperatures. But another big factor is the distance a planet is from the Sun. Fortunately, the Earth orbits in almost a perfect circle around the Sun, which means it receives the same amount of light and heat throughout the year. But the same can't be said for binary star systems, because planets orbiting around these would have a chaotic orbit. It may be a very stretched circle that varies continuously, or it might even be a figure eight as it goes in between the stars, which means the temperatures will vary extremely on the surface of those planets. And if that wasn't complicated enough, star systems like this can contain 3 stars, 4 stars, 5 stars. Star systems can contain as many as 6 stars that we know of. A sextuplet star system, a true wonder of our universe, and one is visible to the naked eye.
When looking north, one of the first things you notice is the Big Dipper. Shaped like a saucepan, the Greeks named the constellation Ursa Major, meaning Great Bear. In the handle of the Big Dipper, you can see 2 stars very close to one another. 13th century Arabs used these stars to test people's eyesight. Although they appear as just 2 close stars, they are actually 6. This is Mizar and Alsor, a quadruple and binary star system that together form a sextuplet star system. Binary star systems can come in many different arrangements. They can be 2 of the same mass orbiting a common centre of mass. They can be slightly different in mass size, like the Pluton-Charon system. There can be more of a difference in mass, like Earth and the Moon, or an even bigger difference, an extreme difference, like Earth and the Sun. Maybe they're even the same mass, but they both orbit in an eclipse, with a common centre of mass between them. This is Albireo, which to the naked eye appears as just another star, but with the help of a telescope it is resolved to be multiple stars. Known as one of the best sights in the night sky, it is easily made out for a pair of binoculars, showing a stunning contrast between the red and blue. For centuries we've been limited to appreciating the beauty of the cosmos with just our naked eye. Now, we are able to resolve the countless wonders of the universe with tools like telescopes and binoculars that our ancestors could only dream of. These marvels have only become known to us in the past few centuries, but they are just the tip of the iceberg in terms of the true wonders out there that are waiting to be discovered. When high-mass stars reach the end of their life, they tend to do something pretty special. This is a supernova, the brightest explosion in the universe. When they happen, they will outshine the entire galaxy before dimming down. The aftermath of a supernova can be either beautiful or terrifying. The size of the star will determine what happens to it after it explodes. Supernovas occur when a star runs out of fuel. Throughout its lifetime, it is in a constant balance between the outward force of radiation and the inward pull of gravity. As the outward force of radiation begins to run out, gravity wins over, and the star collapses inwards on itself, before it either rebounds to produce a supernova remnant, or, if the star is extremely massive, a black hole. The speeds at which the star collapses are fairly close to the speed of light, but the afterglow of the explosion can outshine their host galaxy for weeks. This is the Crab Nebula. It is a supernova remnant, a star that went supernova in the year 1054. It was recorded back then by Chinese astronomers and described as a second sun in the sky. That's how bright it appeared to us here on Earth. So how common are supernovas? Well, typically we expect a supernova to occur in our galaxy once every 100 years. However, we haven't observed one since the year 1604, which means we're long overdue. One star that could potentially be going supernova very soon belongs to the constellation of Orion, and is one of the brightest stars in our night sky.
Now, one of the most iconic parts of the constellation of Orion is Betelgeuse. Now you'll see Betelgeuse on the top right hand side here. It's known as a shoulder star. Betelgeuse is a super red giant. And the reason that's special is because it's on the verge right now of going supernova. In fact, it may go supernova anytime between now and 1 million years or so in the future. Now, because Betelgeuse is relatively very close to us, only 430 light years away, when it does go supernova, it will be visible to us during the daytime. In fact, it'll appear as a second sun. Odds are Betelgeuse could shine as bright as a full moon. But this only lasts for a couple of days because supernovas are very short-lived flashes. In fact, some of them can be brighter than the core of a galaxy. And you think the core of a galaxy is a black hole swallowing thousands, maybe even millions of stars, ripping them apart. So for a supernova to be brighter than that means it's something special. Now, when supermassive stars reach the end of their lifetime, they tend to go out in one of two ways. The really massive ones, with a mass more than 30 times that of our Sun, will form a void in space known as a black hole. But then those that aren't quite as massive, but still have a mass between 10 to 29 times that of our Sun, will form one of the densest objects in the universe. This is a neutron star. Immensely hot, with a mass 1 million times that of our planet, yet only a diameter of 20 kilometers, less than that of most major cities. These are incredibly dense.
The pressure at the core of a neutron star is very intense. The particles that would normally repel each other in any other circumstance are forced together. Protons and electrons fuse to form neutrons. Neutrons have no net charge, meaning they can get as close to each other as they like, leading to these stars being amongst the densest objects in the universe. They have magnetic fields that are trillions of times larger than that on Earth, which is what makes them easier to detect given their small size. In our galaxy, there could be as many as 100 million neutron stars.
Now, in order to show you just how dense neutron stars really are, if you were to take a sugar cube of neutron star matter, then it would weigh the same as Earth's tallest mountain, Mount Everest. This little sugar cube would weigh the same amount as every single human being on planet Earth. All 7.8 billion people would weigh the same amount as this sugar cube of neutron star matter.
But as if they were not enough of a wonder, something truly astonishing happens when two of these stars get too close to one another. They collide and produce what is known as a killer nova. Recently, there have been suggestions that most of the heaviest elements in the universe were not formed from supernova explosions, but instead from killer novas. The likes of gold and uranium form when neutrons become freed and almost immediately coalesce to form these rare elements. There is still plenty to learn about neutron stars, but even now, they are a wonder of the universe. Over the past century, we have solved a lot of the big mysteries in science. Ernest Rutherford discovered the atomic nucleus, Edwin Hubble discovered that our Milky Way is just one of many galaxies, and Watson and Crick revealed the true structure of DNA. But perhaps the biggest unsolved mystery facing science today is what the universe is really made of. Everything you see around you is made up of matter. Matter is anything that has a mass and takes up space. But when we look out into the universe, things don't quite add up. There simply isn't enough matter for things to be the way they are. Galaxies shouldn't really exist as normal matter isn't strong enough to bind them together and form their complex structures. Something else is out there. Something that doesn't produce or reflect light. So we have decided to call it dark matter. It makes up 85% of our universe, as opposed to the 15% that is normal matter. If it weren't for dark matter, then galaxies would not rotate as fast as they do and stay grouped together. Instead, there would be a random arrangement of stars across the universe, as opposed to being a part of supermassive clusters that are galaxies. It does interact with gravity, and as far as we can tell, there must be a lot of it. It seems fair to assume that dark matter is made from an exotic particle that simply doesn't interact with light in any way that we have encountered before. We know very little about it, but it is crucial to understanding the universe and everything in it. In the same way that discoveries about the atomic nucleus and the existence of other galaxies have shaped our understanding of science, it seems only right to assume that when we do one day solve the problem of what dark matter really is, it will become a true wonder of the universe. But for now, it is a mystery.
Space is mostly desolate. It is incredibly vast, but the majority of it is completely empty. However, in the dark stretches of our cosmos, there are infrequent glimmers of hope. There are islands. Islands containing billions of stars, billions of other solar systems. These are galaxies. Massive collections of stars, stellar remnants, interstellar gas, dust, and dark matter, all bound together by gravity. And at the core of almost every single galaxy is a supermassive black hole. Around the central regions are the red dwarfs. These are amongst the oldest stars in the universe. Whilst the outer reaches of our galaxy is filled with young blue stars. The Milky Way is an average-sized galaxy. It has a diameter of 100,000 light years. Galaxies come in many different shapes and sizes. Here are just a few that I've imaged through my telescope. Now the universe is expanding at an accelerating rate. The galaxies are moving further and further away from each other. And one day, we may be unable to visit another galaxy because the space between us is so vast. But one day, we will visit another galaxy without having to ever leave our solar system. In about 4 billion years' time, our nearest spiral galaxy, the Andromeda Galaxy, will merge with the Milky Way. The Andromeda Galaxy contains 1 trillion stars. It's 2.5 times larger than the Milky Way. It will light up the night sky like never before.
The result of these two galaxies colliding will be a new galaxy that is very different to either of them right now. It will be called Milkdromeda and will resemble a giant elliptical galaxy. During this process, it is possible that our own Sun may be flung out of the Milky Way into interstellar space.
Now, when these two galaxies merge, it is very unlikely that any of the stars will collide with one another. And that is because the space in between the stars is incredibly vast. One thing is for certain though, that if anyone is left behind to see this spectacle, then they will be able to truly appreciate what is one of the wonders of our universe. I'm Damon Scotting, and this was Astronomical. These were Ganymede, Callisto, there's people behind me, giggling Asian girls. Sorry. Cheers. You know what, I think the blooper video is just going to be this. Now this is an actual piece of moon rock. It might not look very special, but this is as old as the solar system itself.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
I'm Damon Scotting, and this is Astronomical. 50 years ago today, the history of mankind was changed forever.
It's one small step for man, one giant leap for mankind.
As we set foot on another world for the first time. Just over 100 years ago, we developed the first airplane and left the surface of planet Earth. Now we're closer than ever to leaving footprints on another planet. It is in our genetic code to seek and discover new adventures. We are explorers. I'm Damon Scotting, and this is Astronomical. Now, for the most part of human history, we believed that we were at the centre of our universe, and that the moon, planets, sun and stars all orbited around us. But it wasn't until the 16th century when a Polish mathematician named Nicholas Copernicus disproved this idea. He proposed a new model, a heliocentric one in which we were no longer at the centre, but instead the sun was. This solved many problems, including why planets move in a retrograde motion through our night skies. But it wasn't very quickly accepted. It required a lot of evidence to be built up to support it. One of the strongest points was when Galileo discovered Jupiter's 4 largest moons. Proof that not all bodies orbit around the Earth. Think of the countless generations that grew up and spent their entire lives believing that we were at the centre of our universe. It was truly a reality-shattering realization. Now, although we weren't at the centre of our solar system, what about the rest of the universe? Were we still at the centre of it, or was that not true either?
Up until 100 years ago, we lived in the beautiful ignorance that our galaxy was the full extent of the universe. The millions of stars you were capable of seeing through a telescope were all there is. Then, Edwin Hubble discovered another island of stars that seemed to be very far away. Hubble estimated that they were not within our galaxy, but were in fact 900,000 light years away from us. This was the Andromeda Galaxy. We know today that it is actually a lot closer to 2.5 million light years away, but what Hubble did was expand our horizons further than anyone ever before. Before Copernicus in the 16th century, we imagined ourselves to be at the centre of a universe that ended with the 6,000 or so stars we can see in the night sky. It wasn't until 1924 that Hubble lifted the curtain of our night skies and revealed other galaxies, immense collections of billions and trillions of stars. Based on today's knowledge, we think the universe is 93 billion light years in diameter and contains somewhere in the region of 200 billion trillion stars. But like our ancestors before us, we may be looking at the universe through a microscope. Its true extent may go well beyond our observable universe. Perhaps there may be even multiple universes. The more we explore, the more we discover. Human technological advancements are proceeding at an ever-accelerating rate. At the start of the 20th century, the Wright brothers developed the first airplane and took to our skies for the very first time. A monumental achievement that was to appear practically insignificant just 50 years later. After the Second World War, America and the Soviet Union were going head-to-head in the Cold War. An event that indirectly sparked one of mankind's greatest ever achievements. This was a space race. Each nation was eager to flex their ballistic missile capabilities, which as a result led to the rapid development of spaceflight technology. It seemed as though wars were no longer going to be fought in the trenches, but now instead, the skies high above. Surely whoever controlled the space above our planet would be the most dominant force on Earth. The Russians achieved the first spaceflight milestone by launching Sputnik 1, the first ever satellite, into orbit around the Earth. This caused panic in America. The newspapers were quick to run with a fear that a Russian satellite orbiting above was terrible news for the freedom of their nation. The Americans responded with their own satellite just 4 months later. And they were second place again in 1961, when the Soviet Union launched the first man into space. Cosmonaut Yuri Gagarin. The Americans soon followed, with astronaut Alan Shepard becoming the first American to orbit the Earth. But the humiliation facing the Americans was becoming unbearable. The Soviet Union was winning on all fronts. This failure prompted one of the most powerful and profound speeches ever given in the history of mankind. It would lead us to one of our greatest ever achievements and change the course of history forever.
For we meet in an hour of change and challenge, in a decade of hope and fear, in an age of both knowledge and ignorance. The greater our knowledge increases, the greater our ignorance unfolds. We set sail on this new sea because there is new knowledge to be gained and new rights to be won, and they must be won and used for the progress of all people. Can we help decide whether this new ocean will be a sea of peace or a new terrifying theater of war?
Up until this point, President John F. Kennedy had never been a big supporter of America's space ambitions. He'd recently declined a proposal that would land a man on the moon before 1970, deeming it too expensive. But now, due to recent space failures and the embarrassment that was the Bay of Pigs invasion, America needed a win, and it needed a big one. They needed one that would achieve more glory and was more ambitious than anything ever attempted before. The goal now wasn't just to get a man into outer space. It was to land one on the moon.
But why, some say, the moon? Why choose this as our goal? And they may well ask, why climb the highest mountain? Why, 35 years ago, fly the Atlantic? Why does Rice play Texas? We choose to go to the moon. We choose to go to the moon. We choose to go to the moon in this decade and do the other things not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone, and one we intend to win, and the others too.
The speech resonated not just across America, but the entire world. The goal to land a man on the moon had never been attempted before, and the budget necessary to do so did raise a few eyebrows. But JFK delivered a speech in such a way that ignited the imagination of the entire nation. It is still today one of the most moving and inspiring speeches ever given.
However, I think we're going to do it. And I think that we must pay what needs to be paid. I don't think we ought to waste any money, but I think we ought to do the job. And this will be done in the decade of the 60s. It may be done while some of you are still here at school at this college and university. It will be done during the terms of office of some of the people who sit here on this platform. But it will be done, and it will be done before the end of this decade. And I am delighted that this university is playing a part in putting a man on the moon as part of a great national effort of the United States of America.
Tragically, JFK was assassinated a year later, meaning he would never get to see America finish the path he set them on. The goal to land a man on the moon is still today the most ambitious goal ever set by a nation. It would need plenty of support behind it. America continued on with the mission, regarding it as JFK's legacy. He's still today one of America's most beloved presidents, and this speech is one of the main reasons why.
The pressure was now on to complete one of mankind's most ambitious targets, and to do so before the decade was up. NASA announced a number of programs and missions that would slowly prepare us to land on the moon. However, after a disastrous start to the Apollo program with Apollo 1 that led to the gruesome deaths of all 3 astronauts, the mission was under more scrutiny now than ever. It was going forward at a relentless pace that NASA seemed unable to keep up with. Nevertheless, they kept going, with the next few Apollo missions containing no crew. By Apollo 8, they had a manned crew successfully complete an orbit around the moon before landing back on Earth, achieving one of the most magnificent photos ever taken. This is the Earth rise.
Oh my God, look at that picture over there. There's the Earth coming up. Wow, is that pretty? Hey, don't take that, it's not scheduled. You got a color film, Jim? Hand me a roll of color quick.
Oh man, that's great. Where is it?
Quick.
11.
Apollo 9 and 10 were the last dress rehearsals that prepared us for the most important mission to date, Apollo 11.
2, 1, 0.
The first mission that would attempt to successfully land a man on the moon and then return them back to Earth.
Liftoff. We have a liftoff.
Neil Armstrong, Buzz Aldrin, and Command Module pilot Michael Collins were all preparing to make history. Then, on July 16th, 1969, the Saturn V was launched. The most powerful rocket ever built. America held its breath as they began their journey.
Many years ago, the great British explorer George Mallory, who was to die on Mount Everest, was asked why did he want to climb it. He said, because it is there. Well, space is there, and we're going to climb it. And the moon and the planets are there, and new hopes for knowledge and peace are there. And therefore, as we set sail, we ask God's blessing on the most hazardous and dangerous and greatest adventure on which man has ever embarked. Thank you.
30 feet, 2.5 down. Straight shadow. 4 forward. 4 forward. Drift into the right a little. Down a half. 30 seconds forward. Just contact light. Okay, engine stop. ATA at a descent. Mode control both auto, descent engine command override off. Engine arm off. Port 13 is in.
We copy you down, Eagle.
Houston, Tranquility Base here. The Eagle has landed.
Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
Thank you.
Neil Armstrong then wrote himself into history, gaining immortality as he took his first steps on another world. He then uttered some of the most famous words to ever be spoken.
That's one small step for man, one giant leap for mankind. Beautiful view. Isn't that something? Magnificent sight out here. Magnificent desolation.
Buzz Aldrin joined him on the surface 20 minutes later. The two gathered samples of moon rock and conducted a few experiments before then heading back to the command module and returning to Earth as heroes. JFK's goal had been reached. America's dream had been achieved. Although they were outperformed by the Soviets throughout most of the space race, they had beaten them towards arguably the most ambitious goal, leaving footprints on the moon.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth. No single space project in this period will be more impressive to mankind or more important for the long-range exploration of space, and none will be so difficult or expensive to accomplish.
America didn't stop with Apollo 11. They carried out 6 more subsequent missions, 5 of which were successful. Each new mission was more daring and aspiring than the last. The goal now was to gain more scientific data surrounding the moon and the solar system's formation. This is a 3D model of the Apollo 15 landing site. One of the main issues that faced the astronauts on these missions was they couldn't venture very far from the lunar module, because the spacesuits they were wearing were very heavy. So, in order to get around this problem, on Apollo 15 they introduced the Lunar Rover. As America had reached its goal, the Apollo missions became less and less appealing to the general public, and the funding was cut, meaning the Apollo 17 mission was to be the last. Gene Cernan is, as of today, the last man to walk on the moon.
99, proceeded, 3, 2, 1, ignition. Right away, Houston. America's challenge of today has forged man's destiny of tomorrow. And as we leave the moon in Taurus Littrow, we leave as we came, and God willing, as we shall return, with peace and hope for all mankind. Godspeed to crew of Apollo 17.
The Apollo missions captured the public's imagination like never before. But this is just the beginning of our exploration of space.
Do you see that bright star-like object just over there? That's not a star, and it's not a plane either. That is the International Space Station. It's moving at 17,500 miles per hour, and aboard it right now are 9 astronauts. They're moving around the Earth so quickly that in 24 hours they'll see 16 sunrises and 16 sunsets every single day.
The ISS is a modular space station in low Earth orbit. It is a result of communal efforts from America, Canada, Japan, Russia, and Europe's space programs. Roughly the size of a 6-bedroom house, it is the perfect environment for astronauts to conduct tests on human habitation and how well we adjust to the effects of microgravity, ultimately determining whether or not future missions to other worlds are viable. The International Space Station has never managed to capture the public's imagination quite like the Apollo program did. Nevertheless, the public are becoming increasingly involved with the activities being carried out during these scientific missions. Astronauts often work long, hard days aboard the ISS, but they still generally manage to find time to teach the rest of us about life in space, and how even the most mundane, simple day-to-day tasks that we do here on Earth can prove quite challenging. The long-lasting effects from living in outer space can lead to some very serious health problems. At the moment, astronauts rarely spend more than 6 months in outer space at a time. It is very important to monitor an astronaut's health after they return back from space, in order to ensure there are no long-lasting effects. Setting up a habitat on another world is a long-term goal. We are not quite there yet, but we are moving closer and closer to having the first ever humans live for long periods on another world besides the Earth. At its closest approach, Mars is still 8 months away from us in terms of travelling through space. This presents a number of potential challenges for the crew to deal with alongside the main goal, which would be to explore Mars in greater detail. Although the idea of producing a viable habitat on Mars seems a little out of reach at the moment due to Mars's hostile environment, there are ways in which we could manipulate Mars's atmosphere in order to replicate that on Earth. If we could do so, then Mars may become a suitable second home that is becoming increasingly more necessary given the way we are treating this planet. But the possibilities for new worlds to live on doesn't end there. Although none of the other planets present much chance of settling down and establishing a colony, there are a large number of moons that hold the ingredients that may harbour life. Enceladus and Europa each orbit one of the 2 largest planets in our solar system, Saturn and Jupiter. These 2 worlds do have similarities, in that they both have a very large potential for extraterrestrial life being found beneath their icy crust.
Now when Europa orbits Jupiter, it does not do so in a perfect circle. Its orbit is slightly squashed, which means there are points when it goes around Jupiter where it's closer and further away. This causes the core of the moon to warm up for a process known as tidal heating. So beneath its frozen icy surface, the oceans of water are being warmed constantly. This makes it an active moon and perhaps the ideal environment in which life could arise. The same applies for Enceladus. Perhaps one day we could live beneath these frozen icy surfaces.
Titan is Saturn's largest moon. Much like Earth, it has a thin blue line encircling its atmosphere. This dense, hazy world has remained a mystery to us for a long while. We wondered what lied within the dense atmosphere. So, we sent the Huygens probe to land on the surface and investigate.
Now when we landed on Saturn's largest moon, Titan, one of the first things we noticed were the rocks on its surface. These resembled those we'd find on Earth. More specifically, those around a riverbed. This brought us to the same conclusion, that these rocks have been eroded by a body of water. And indeed, the Cassini probe orbiting around Titan discovered very large lakes of liquid methane. Now on Earth, methane is a gas, but when the temperatures are lower, it can become a liquid. And indeed, that is the case on Titan.
As the sun reaches the end of its lifetime, it will swell into a red giant, warming the outer reaches of the solar system. The Earth's oceans will be boiled away, but there is a high likelihood that the cold distant moons of our solar system could be warmed to a suitable temperature, allowing us to colonise all of them. One day, we may need to leave our solar system in search of another star that gives us the energy and support we need to continue and further advance as a species. This would require travelling through interstellar space, the space in between stars. If the trips to Mars and other moons seemed long and risky, they are a taste of paradise compared to the extreme conditions of interstellar travel. The distances between stars is incredibly vast. It will not be an easy journey for us to make if we are to ever travel to another solar system. But our desire and relentless curiosity means it is practically inevitable that we will one day venture to other stars.
Our knowledge of the universe's true size has grown tremendously in recent times. But there is still nothing to say we fully understand its true extent. With every second, the universe is expanding more and more. But this just simply means there is more space for us to explore. As a species, we are no longer limited to our own skies. The universe calls to us. It awaits our arrival. Exploring our own solar system will be the first steps towards colonizing the galaxy. We are explorers. I'm Damon, and this was Astronomical. There could be a lot more. I should have prepared the speech, and I'm going to do that when I get back, work on the speeches more. Okay, coming in from afar. All right, 3, 2, 1. One day, oh wow, the cameras, no! Larger than our own, went supernova. It scattered its enriched goods across the universe. Goods made of, Need to sneeze now. I can't start talking until I need to. Have you got that in slow-mo? No, now my nose is bleeding. Who the f bleeds? It's so warm. Okay. Do I leave the boot behind? I'm so tired. How big is Uranus? Not big enough. If you want to know how big the planet Uranus is, then that's about 51,118 kilometers in diameter at the equator, which is very large. It's about 4 times the diameter of Earth. Uranus is a gas giant, but when it was discovered by William Herschel, he wanted to name it after King George himself. So, at its time of discovery, it was known as Planet George, which means the gas giants went as Jupiter, Saturn, George, Neptune. But sooner or later, people decided that that was a dumb name for a planet. So instead, they named it after the Greek god of the sky, Uranus. And make sure you remember that part. If you take anything from this video, remember that. Not Uranus, Uranus.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
I'm Damon, and this is Astronomical. One day, the sun will die. As it does, it's going to swell into a red giant, over 100 times its size at the moment, and engulf the Earth. It's going to boil our oceans, burn the planet to a crisp, and eliminate all life on our surface. In fact, one day, the last star in the universe will die. And as it goes out, the universe itself will be cast into eternal darkness. There will be nothing left. So the question is, when will the universe die? I'm Damon, and this is Astronomical. Now in the first episode, we look back to the birth of our universe and how after 13.8 billion years we got to where we are today. Now, in the series finale, we're going to look forward in time and figure out just how and when the universe will end. So let's start with a small leap forward in time. How different will our universe look in just 10,000 years? Come with me as we venture into the future.
In 10,000 years, the red supergiant Antares will go supernova. It is a star 12 times the mass of our own Sun, with a diameter roughly 500 times larger. If it were to swap places with our Sun, then it would extend beyond the current orbit of Mars. The resultant supernova will likely shine as bright as a full moon and be visible to the naked eye during the daytime. There will be a simultaneous total solar eclipse and transit of Venus. Vega will become the new North Star as constellations start to become unrecognisable. This will be the end of the projected lifespan of the Svalbard Global Seed Vault. The vault preserves an enormous variety of plants and seeds from the event of a global crisis. The Sahara will become tropical. Voyager 1 will move to within 3.4 light years of our nearest stellar neighbour, Proxima Centauri. The Chernobyl exclusion zone will return to normal levels of radiation. The northern polar ice cap on Mars will begin to recede as the red planet reaches a warming peak in its northern hemisphere.
"10,000 years was the most probable lifespan of a civilization according to the Frank Drake equation. But if we make it beyond that, to say 1,000,000 years, then we will be around to witness some truly special events.
After 1,000,000 years, Neil Armstrong's and the rest of the Apollo moonwalkers' footprints will have disappeared from the surface. The Great Pyramids of Giza will have eroded beyond recognition. The stars in our night sky will have moved independently at different speeds throughout our Milky Way. This will lead to constellations no longer resembling the way they appear to us now. By this point, the red supergiant star Betelgeuse will have exploded into a supernova. For at least a few months, the supernova will be visible to the naked eye on Earth. There will now be a void in the shoulder of Orion. We will have surpassed the time required to terraform Mars. This is an optimistic and pessimistic moment in time, depending on the way you look at it. It is the shortest estimated time by which humanity could potentially colonise our Milky Way galaxy and become capable of harnessing all the energy of the galaxy. This is largely based on the assumption that we will be capable of reaching a velocity that is at least 10% the speed of light. But there is also a 95% probability that humanity will be extinct by this date, according to the doomsday argument. There will likely have been at least one eruption of a super volcano. Mars's two moons, Phobos and Deimos, will collide and form a ring encircling the red planet. Whilst much further into the future, 100 million years or so, the rings of Saturn will have disappeared. The Sun's luminosity will have increased by 1%. This is the beginning of the end for our solar system.
As the Sun grows in size and luminosity, the region around it, known as the habitable zone, where it's not too hot and not too cold, will expand with it, meaning the Earth will likely boil away. So in order for us to stay alive, to stay on a habitable world, we will need to move the Earth further away from the Sun. This will require a grand astro-engineering project. We'll need to use asteroids to give us gravity assists to move further away from the Sun. In 5 billion years, one of the greatest night sky spectacles will take place as the Andromeda Galaxy and Milky Way merge.
Over the course of the next few billion years, these two galaxies will engage in a beautiful celestial ballet. Very few stars will actually collide with one another whilst this is happening. This is due to the vast distances in between the stars. But there will be a considerable number of stars that are ejected from this new galaxy that is to be known as Milk-Dromeda. Now that the hydrogen supply at its core is exhausted, the Sun will start to leave the main sequence phase and evolve into a red giant. The Sun will engulf the Earth and Moon. By this point, however, any life that was left on the Earth will be long dead, due to the new searing temperatures on its surface. The Sun will swell to as large as 256 times its radius today. Although this is terrible news for our planet, assuming we cannot do anything to alter its distance from the Sun, this will be a new era of life elsewhere in the solar system, as moons such as Titan will likely reach surface temperatures that are now suitable for life.
Now this is a very peculiar point in the life of the universe, because it can take one of three different routes, and this depends largely on the rate at which it continues to expand. The universe could end as early as 22 billion years from now, in what is known as the Big Rip.
The Big Rip model of the universe is based off the idea that the expansion of our universe will start to increase to infinity in a finite time, meaning all matter in our universe, including every galaxy, star, subatomic particle, even space-time itself, will be ripped apart, leaving nothing behind. This idea depends on the amount of dark energy in our universe. This affects the rate at which the universe expands. So if dark energy can increase without limit, then we will reach a point where it will overcome all of the forces that hold our universe together. This is just one potential end to our universe.
Now if the universe does continue to expand, then our nearest galactic groups will move so far apart from one another that we will no longer be able to see them. The redshift from these galaxies will be beyond our point of view, meaning any civilizations that are born after this point in time will look out into the universe and see only our local galactic group and think that is all there is and all there ever was.
Galaxies are very far away from one another. It is unlikely that we will ever be able to venture to a galaxy outside our own local group, as the universe's continuous expansion is stretching us further and further apart, meaning we will need to be able to one day find a way to travel across these immense cosmic distances in a small region of time. If we don't, then they will have all moved well beyond our view. The universe contains somewhere in the order of 200 billion galaxies that we know of. Any newborn civilizations at this point will look out into the night sky and see only the few within our local group, and accept that this is all there is out there, and all there ever has been, because there is no proof otherwise. Their entire universe will consist of the few trillion stars within our local group.
However, if the universe does begin to stop expanding and instead starts contracting on itself, then this will be a far more optimistic end to our universe's life, as all the galaxies that were once too far from one another to see each other will now begin to contract and slowly coalesce until a point of single infinitely dense mass, and then perhaps a big bang. The universe will continue to repeat itself in what is known as the Big Crunch.
The Big Crunch scenario assumes that the density of the matter in our universe is high enough that everything will soon begin to contract under the influence of gravity, overcoming the expansion of our universe. This theory is also referred to as the Big Bounce. The galaxies will all slowly start to merge together, and the temperature of the universe will increase so much that it will now be hotter than the surface of most stars, before eventually collapsing into a singularity, and then maybe, just maybe, producing another Big Bang. This could be the way in which our universe was formed. Perhaps this is the cycle of the universe. There is never an end, just a new beginning.
But out of all of these potential outcomes, perhaps the most likely of them all is the Big Freeze. Otherwise known as the heat death of the universe, it's based on the idea that it will continue to expand forever. And at this point in time, 10,000 times the current age of the universe, no more stars will be born. It will be the end of the Saliferous era. There will be no more starlight in the universe, and it will be the beginning of the degenerate era.
All of the stars in the universe have now exhausted their fuel. In what was once a rich galaxy filled with trillions of stars, there are now only 100 remaining in our Milky Way. The longest living stars, such as the low-mass red dwarfs, have a lifespan that is approximately 10 to 20 trillion years. But soon they, alongside the white dwarfs, brown dwarfs and neutron stars, will all die out. The only new stars that will be born during this period are through incredibly rare star collisions. They will lead to supernovas and a new star will be born, but will not last very long. One day, the last star will go out, and the universe will be cast into eternal darkness. This is the beginning of the black hole era.
Now at this long distant point in the future, the only source of fuel for an exotic civilization will be that from a rotating black hole. But even black holes die. After the last one has disappeared through Hawking radiation, there will be no more black holes left. At this point in time, it is 10,000 trillion, 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 trillion years into the future.
Any hope of harnessing energy in this now bleak universe will likely come from using the rotational energy of a black hole. Black holes were once believed to be eternal, until Stephen Hawking discovered that along the event horizon of a black hole, the region known as the point of no return, there were interactions between particles and antiparticles. When the two separated on the very edge of the event horizon, one would be swallowed and trapped, whilst the other broke free. Through this process, black holes slowly release energy, and after incredibly, immensely, ridiculously long periods of time, they start to dissipate. and the universe becomes even emptier. As the last black hole dies, there is nothing remaining. This is now the Dark Era.
Now the last possible outcome for the universe is the Big Freeze, otherwise known as the heat death. And this is based on the idea that the universe will continue to expand forever. And after the last particles are removed from existence, there will be nothing. No movement, no activity, no life. Time will have become meaningless. This will be the end of time. Now, the end of the universe might seem pretty bleak. It might make you question, is there any meaning to life at all? Well, the answer is yes. Right now, we're at the beginning of our journey. We as a civilization have existed for the cosmic blink of an eye. The best is still yet to come. One day, we will venture to another solar system. One day, we may encounter alien life. One day, we will die. But our inevitable demise won't occur before we venture out to new worlds and new stars. 100 years ago, we didn't know there were other galaxies out there. 400 years ago, we believed we were at the center of our solar system. Imagine how small our universe would have seemed back then and how big it is now. Right now, we're living through the golden age of exploration. And you might take joy in the wonders the universe has waiting for us. We are just a few cosmic steps away from discovering them. I'm Damon Scotting, and this was Astronomical. So how long does it take to get to space? Well, believe it or not, at any given point on the surface of our planet, you are always roughly 100 kilometers away from space. Now that might seem a bit shocking, considering most people will drive further than that every morning to get to work. This right here is the Saturn V rocket. It's the most powerful rocket ever launched. It took 8.5 minutes to leave Earth and reach space. And the astronauts aboard it will experience 3G during the launch process. Now that's the same as you'd experience on one of the most intense roller coasters you can find. But you'd only feel it for a few seconds. Astronauts aboard a Saturn V rocket like this will experience that feeling for 8 or 9 minutes. And then when they reach the Earth's atmosphere, it will drop from 3G almost instantaneously to 0G. Which is a very intense feeling, and not many can deal with it, which is why to be an astronaut, you need to have the right stuff.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1.
I'm Damon Scotting, and this is Astronomical. What is the biggest thing in our universe? Is it a star? A black hole? What about a galaxy? In fact, how big is the universe anyway? And what is it all made of? What is the smallest thing in the universe? Depending on the way you view our cosmos, it is either really small or really big. I'm Damon Scotting, and this is Astronomical, Season 2.
For many of us, we are taught in school that the atom is the smallest thing in our universe. But where did the idea for an atom come from? Now 2,600 years ago, there was a Greek philosopher named Democritus who had a very profound thought. Whilst cutting things up, he thought to himself that there must be a point where whatever it is that you're cutting can no longer get any smaller. You must eventually reach what is the building block of our universe. And he described this as atomos, which comes from the Greek words for not cuttable. Now it wasn't until the 19th century that we realised the atom wasn't the smallest thing in our universe. In fact, it gets a lot smaller. This is an atomic model. Now you've probably seen this before. At the core you have the nucleus made up of protons and neutrons, and on the outer edges you have the electrons. Now this is a very loose idea of what an atom will look like. The reality is far different. Now at the start of the 1800s, a man named John Dalton discovered different chemical compounds have different sizes. So in this analogy, we're going to say that this chemical compound is carbon. And when you look a little bit deeper into this chemical compound, you find individual carbon atoms, which at their core are protons and neutrons. Now you might think that this is the smallest thing in the universe, but it actually gets a lot smaller. Protons and neutrons are made up of things known as quarks, which are very quirky. Quarks come in 6 different variations. You have up quarks, down quarks, top quarks, bottom quarks, charm quarks, and strange quarks. Now depending on the way these are arranged or grouped together determines the particle it makes. 2 up and 1 down quark makes a proton. 2 down and 1 up quark makes a neutron. But you can also make antiprotons and antineutrons and a whole variety of different particles. And for many people, the quark is the smallest thing in the universe. But for some, there is something even smaller. And this is string. The idea is known as string theory, and it's based on the thought that everything is made up of small, vibrating strings. They can come in 2 different types. They can come in closed loops or they can come in open-ended loops. And depending on their vibration and frequency determines the particle in which they produce. Everything around you is made up of these vibrating strings. Now this is the size of a proton, not the size of a quark or even the Planck length. No, they are far smaller than this, which is already an incredibly small number. The size of a proton or neutron is 0.87 femtometers. Look how many zeros there are. There's 15 zeros before you reach a number down here. It is incredibly small. That is the Planck length, the smallest possible distance or measurement in our universe. Sure, you can think of a number smaller than this, but as far as we are aware, judging by the fabric of space and time, this is as small as you can possibly get. 1.6 times 10 to the minus 35. That's 35 zeros. Think how small the proton was. Think how many zeros that is, and then compare it to the size of the Planck length. Incredible. Absolutely ridiculous. And although the universe itself is very large, and we are going to explore that momentarily, the difference between the small scale of the universe to the vastness of the universe is far greater. The universe is much smaller than it is bigger. Now as a kid, I thought that the smallest thing in the universe were cells. I was aware what molecules were, but being told that there's trillions of these everywhere you look just didn't add up. But what I could see were cells. I could see thousands of them. They were interacting with one another independently. I could see it with my own 2 eyes. And that's because molecules and atoms are very small. They're too small for you to resolve with visible light. They are smaller than the wavelength of visible light. So in order to see them, you have to use specialized equipment. You'd have to use an electron microscope. But if you go down to the lakes and bring back a sample of water and place it under your microscope, then you will resolve a mini cosmos. There are thousands of lives all moving about underneath this microscope, all moving around under such a small surface area. It really is incredible. Wrong glass of water. They are about a micrometer in size, which means compared to us, we are 1,000,000 times larger than they are. So as far as they're aware, we must appear as giants. We must seem incredibly big.
So we're now going to move on from looking at small sizes such as bacteria, molecules and atoms to some of the biggest objects in our universe. The reason the scale of the universe is so hard for us to understand is because there's rarely any context. When we look up at the night and see the stars, we can't just pull out a tape measure and determine their size. In fact, the way we do so is by measuring their luminosity and their parallax. So we're going to look at 3 different scales: everyday objects, dwarfs, moons and planets, and stars, including the largest known star in our universe.
A bit like stars, it's very hard to judge the size of space probes, telescopes and rockets without any other context that you're familiar with. Hopefully this helps you to understand their true size.
So in order to make things easier to understand, I'm going to talk about the scale of the universe in 3 different stages. The first of which will involve everyday sizes. So our unit of measurement will be me. Everything you see before you is going to be to scale. And if that's too confusing, then here's a velociraptor. So, firstly, a Martian rover, or to be more specific, the Curiosity rover.
I personally imagined all of the Mars rovers on Mars to be no bigger than a shopping cart.
Its height is 2.2 meters, which means it's somewhere between my height and that of an elephant. Then we have the Hubble Space Telescope, our largest space telescope at the moment. Its primary mirror is 2.4 meters in diameter, whereas lengthwise it is 13.3 meters, which is very large. But this is nothing compared to its successor, the James Webb Telescope. Its mirror is 6.5 meters in diameter and will dwarf Hubble. Then we have the most powerful rocket ever launched by man. This is the Saturn V rocket. It's almost 111 meters high, which means it's almost 3 times higher than the rocket tower behind me. We're now going to move on from everyday objects to moons, dwarf planets and planets. And our unit measurement for this is going to be a bouncy ball. And the first moon we're going to start off with is one of my favorites. This is Mimas, otherwise referred to as a Death Star moon. Now this is 390 kilometers in diameter, and it's going to be our unit of measurement. So for every 130 kilometers you see, that will be 1 centimeter. Also, if the planets seem a bit smaller than usual, it's because it's cold. So the first object we're going to start with is the dwarf planet Pluto. And I want to emphasize that point. Pluto is a dwarf planet. There are a number of criteria that you need to meet in order to be a planet, and Pluto doesn't do so. Some of which include orbiting in the same plane as the Sun, which Pluto does not do, does at a 23-degree tilt. You also need to have cleared the path in which you orbit, hasn't done so. It's very small, and its largest moon, Charon, is very similar in size, meaning this could be considered to be a binary planetary system. Then we have Triton, Neptune's largest moon. So hopefully this sets the tone. There are plenty of moons larger than Pluto. Then we have Europa, which is the first of the Galilean moons. Europa is also considered to be one of our best chances of finding life elsewhere in the solar system. Beneath its frozen surface is more liquid water than there is on the whole of planet Earth. This is a world that is alive. Then, just a bit larger than Europa, is our moon, which we are all too familiar with. Then we have the next Galilean moon, Io. This is the most volcanic world in our entire solar system. It's soon followed by Callisto, and then Mercury, the closest planet to the Sun. But then perhaps surprisingly, just a bit larger than Mercury is Saturn's largest moon, Titan. Now Titan is the only moon to have a thick atmosphere, much like we do here on Earth. But this isn't the biggest moon in our solar system. That title belongs to Ganymede, the last Galilean moon, which is the largest in our solar system. These two moons, Titan and Ganymede, are each bigger than Mercury. Moons bigger than a planet. Who would have thought? But like I said, you need to meet certain criteria to be classed as a planet. Mercury is all alone with no moons, very close to the Sun, whereas these guys orbit around gas giants, which compared to them are enormous. Then, much larger than Ganymede, we have the red planet Mars. Next is Earth's sister, Venus. I have to say Earth's sister this time because in the first episode of the first season, I said Earth's hot sister, and I got a few comments about that. What I mean when I say that is Venus is over 400 degrees Celsius, whereas our planet Earth, is on average about 12. These are the inner rocky planets and some of the largest moons, but their size is almost nothing compared to the gas giants, the smallest of which is our most distant planet, Neptune. But it isn't too different in size to that of Uranus. These two are dwarfed compared to the other gas giants. The first is the gem of our solar system, Saturn. Now Saturn now has the most moons in our solar system with 82. It also has this extensive ring system that extends for twice as far as the diameter of the planet. And lastly, we have the god of all planets, Jupiter. It is so large that it could fit our planet, planet Earth, inside it 1,321 times, which is a ridiculous number. There is a storm on the surface of this planet, referred to as the Great Red Spot, that could swallow our planet 3 times whole. Now that is one of the most ridiculous and perhaps terrifying things that you can imagine. A storm that can consume our planet multiple times over. So that's it. These are the dwarfs, the moons and the planets in our solar system. Which means we now need to move on to our next scale, the stars. Our closest stellar neighbour is Proxima Centauri, 4.26 light years away. And it might seem smaller than you may have imagined. Proxima Centauri is about twice the size of Jupiter. It is a red dwarf, but don't let this mislead you. The rest of the stars are far bigger, including our Sun. So now we're on the scale of stars, and stars are really big. So for this scale, we're going to say that our Sun is this size. That right there is our star. So firstly, we have Polaris, the North Star. Now Polaris, bag. Son of a bitch. Oh no. Oh, I should have done that. I should not have done that. So Polaris is about 37.5 times bigger than our Sun. When the Sun reaches the end of its lifetime, it's going to swell into what is known as a red giant, 256 times its size today. Which again is nothing compared to the size of other stars, such as the Pistol Star. Then we have the super red giant that occupies the shoulder of the Great Orion constellation. This is Betelgeuse, a super red giant. But now we're going to move on to the giants of our universe. Stars so big it seems impossible to imagine. This is UY Scuti. Now you won't find a name in astronomy that sounds more space and physics than UY Scuti. It's about 1,708 times the size of our sun. But again, even that is small compared to what was, up until last year, the largest star in our universe. This is VY Canis Majoris, over 2,000 times the size of our sun. But as of right now, in the year 2020, there is a bigger star. As we know of right now, the largest star in our universe is Stephenson 2-18, which is 2,150 times the size of our star. So, just to put that into context, in case you don't already understand, if our star is this big, that is its size compared to Stephenson 2-18. Our sun is nothing but a speck of dust compared to this monster. In fact, if you replaced our star in the center of our solar system with Stephenson 2-18, then the star itself would stretch out far enough to reach Saturn. It is enormous. So I suppose the question still remains, are we big or are we small?
It is a common belief that the human race is special. And in many ways, we are. As far as we are aware, we are the only intelligent life forms around, but perhaps we are not appreciating the true immense scale of our universe. It's easy to take 2 steps into the woods and declare that there are no bears around, but it's also very ignorant. Moving out past our solar system, you can see the hundreds of billions, maybe even trillions of stars that make up our Milky Way. An ocean of stars, the vast majority of which make up their own solar systems. And that ludicrous thought that there might be millions of different worlds out there, each with their own forms of life, is only made all the more ridiculous as we see the billions of other galaxies out there in the universe. On this scale, every point of light, every dot, is an entire galaxy. Some smaller than our own, some a lot bigger. But when viewed on a large enough scale, our universe displays order. The galaxies are grouped together. This is what is known as the cosmic web. As tremendously vast as our entire universe is, it is only the observable universe. This is all we can possibly see. 100 years ago, we were yet to discover the first galaxy outside of our own. Our universe was relatively small, but it may in fact be just one universe of many, maybe even an infinite number of multiverses, a scale beyond comprehension.
Now I think I know how you're feeling right now. You're feeling small. And if that's the case, good. Because you now understand the true scale of our universe. It is enormous. It is 93 billion light years in diameter. That's 88 billion trillion kilometers. Which means it's 8.8 with 23 zeros after it. It's huge. So yeah, it's easy to feel insignificant or like you have no purpose on the grand scale of things. But it's also important to have context. If you were to make a scale of our universe and had the smallest thing in our universe, the Planck length on one side, and had the size of the universe itself on the other, then we humans would pop up around about here, which means we're a lot bigger than the average size in the universe. It's easy to feel small on our planet. Our planet is huge. It's very unlikely that you'll ever go on to explore every single country or continent on our planet. But when viewed from Saturn, it appears nothing more than a pale
blue dot. And if you go further out towards the edge of our galaxy, then our star becomes indistinguishable. You cannot make it out amongst the other trillion stars. And yet, if you go all the way out to the edge of the universe and look in towards the cosmic web, then we are nothing more than an insignificant speck of dust on the grand scale of the universe. When you think about the first forms of life that appeared on Earth, they were single-celled organisms that were no bigger than a micron. Which means we now, after evolving from them, are 1,000,000 times larger than they were. Now, I'm not saying we're going to grow 1,000,000 times in size over the next couple of years, but the point I'm trying to make is size is relative. And compared to the small atomic scale of the universe, we are enormous. The fact that the universe is so large shouldn't scare you or terrify you. It should make you excited, because there is so much of it yet to explore. Perhaps we never will, perhaps there is really too much of it. But either way, it's an exciting life to live. I'll let you answer the question yourself. Do you feel big or do you feel small? I'm Damon Scotting, and this was Astronomical.
No! Remember when you're growing up and you're watching those cartoons and you see them deal with quicksand and you think, you know what, I'm ready. When it comes to dealing with quicksand in real life, I'll be ready. And then you get older and you think, why did they teach us that? We're never going to need to learn that. Well, now I could have really used that information. And still do today. These are just a few of the wonders of our universe. Okay, let's go again. When we look up at the night sky, we can see roughly 6,000 stars with the naked fuck. See how big that bat was? Yo! That was fucking huge. Well, that's enough filming for forever.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
I'm Damon Scotting, and this is Astronomical.
In life, just like in video games, there are ways to enhance your experience through the use of equations. In this video game, there are a set of rules that you must abide by. Much like how in our world, we have physical laws. These are the laws of physics and they cannot be broken. But if you know enough about these laws, you can predetermine the outcome of a situation. Through the use of a few simple equations, you can get the universe to do your bidding. These are the cheat codes of the universe. I'm Damon Scotting, and this is Astronomical.
Now, if I was to ask you to think of an equation, it's likely that the first one that comes to your head is E equals mc squared. It is by far the most popular equation in all of physics. Now, it might look confusing, but it's actually very simple. It states that the energy of a system is equal to the mass of a body multiplied by the speed of light squared. That's it. And the reason this is so profound is because for so long we've always thought that to have energy, a body must be moving in some way or another. it must have a velocity. But what Einstein discovered was that all matter can be converted into pure energy. And the speed of light is a very big number, even more so when you square it. So what this means is that anything around us, regardless of how small, has a tremendous amount of energy. Let's take this rock for an example. Let's say this weighs 25 grams. Now if we plug that into the equation, that means the energy of this rock is 0.025 kilograms multiplied by 9 times 10 to the power of 16. Which means this rock has enough energy to power the entire United Kingdom for a whole second. Every light, every toaster, kettle, TV, refrigerator, everything that is powered by some form of energy in the United Kingdom could be done so for a whole second by this rock. Now we are yet to figure out a way to do so. We always lose some energy in the form of one process or another. It's always given off in a form of heat or sound. We lose it that way, so we can't convert all of the mass of a body into pure energy. And the possibilities to what we could do with that amount of energy are endless. If you took my mass and converted it into pure energy, then that would be enough to power the entire United Kingdom for almost an entire hour, which is just ridiculous. Equations allow us to figure out the solution to a problem without ever having to go through the physical process. That is why they are deemed the cheat codes of the universe. You can figure out the answer to a question without ever having to lift a finger. A real life example is just behind me. That is Big Ben, one of London's most iconic sites. And right now it's going under refurbishment, which means there is scaffolding surrounding the tower. If I was to go to the top of Big Ben and drop a bouncy ball from its 96-meter peak, how long do you think it'd take for it to reach the ground? Now you could have a variety of guesses at this. You could say it takes 2 seconds, you could say it takes 20 seconds, but you'd never know for sure without going up to the top of it and dropping this ball, except without the help of an equation. And this one is very simple. So we have h, which equals the height, the point at which you are from the ground, equals half multiplied by g, which is the gravitational force you experience. Throughout the majority of our planet, you will feel 9.81 meters per second squared. It doesn't vary much depending on if you're on Mount Everest or if you're at the lowest point of Earth. And then finally, we have t squared. Now t squared is time multiplied by itself. So we know the height of Big Ben, which is 96 meters. We know the gravitational constant is 9.81 meters per second squared, which means we can figure out the time it takes to reach the ground. The time it takes for this ball to reach the ground dropped from the height of Big Ben is 4.42 seconds. And I've done that without having to climb Big Ben like I was King Kong. It does work both ways though. If you were to go to a tall building and then drop a ball like this, assuming no air resistance, and measure the time it takes to reach the ground, you could calculate the height of that building. But perhaps that equation isn't very useful for you. You might not use it every single day. But there are equations out there that people use all the time and have changed and transformed the way we see our planet. There's one equation that unlocked the seas and allowed us to travel across the ocean. That boat moving across the Thames behind me is only doing so because of one man's brilliance, and his name was Archimedes. And it's because of him we could travel to different continents and conquer our entire planet. That cheat code unlocked the rest of our world. This is a story of the Eureka moment by Archimedes. It all started when the king of Syracuse paid a goldsmith to make him his latest golden crown. But he felt suspicious of the goldsmith. The crown seemed to be lighter than expected. He thought maybe he had snuck in some silver alongside the gold, but there was no way for him to prove that he did. Which is why he then tasked a 22-year-old Archimedes with this problem. Now the problem was, a crown is an irregular shape, which means it's very hard to measure its volume. And Archimedes was under strict instructions that he should not damage the crown in any way. He was puzzled by this challenge, and he was one of the great thinkers of his time.
In fact, the solution wouldn't come to him until one day when he was in the bath. See, as Archimedes lowered himself into the bath, he wondered, why does the water trickle out? Now this is something we've probably all noticed ourselves, but his genius was to realise that the amount of water that was displaced was in correlation with the volume of the body added to it. So, if you had an irregular shaped object, like a crown whose volume is very hard to measure, all you have to do is measure the amount of water displaced and you can determine the volume of the object. Then, from that, the density of it, and determine whether or not the goldsmith was in fact cheating. In this moment of brilliance, he was so overcome that he leapt out of the bath and ran through the streets completely naked, screaming, "Eureka, Eureka," which in Greek means, "I got it, I got it." But that's a part of the story we don't need to reenact. Oh. Whoops.
Now, if you've ever thought about taking over the universe, there are a few things you need to know beforehand. One of which is the laws that govern the universe. Perhaps the most fundamental is the gravitational law. This was proposed by Isaac Newton in the 17th century, and it states that any two points of mass will have a force of attraction between them, and the sum of which can be calculated by multiplying these two masses and dividing them by the square of the distance between them, and then multiplying all of that by the gravitational constant. Now I know that might sound confusing, but it's not. I know all equations might look confusing because at the end of the day, they are just a couple of letters with some very small numbers nearby. There is rarely any context to them. But I'm going to explain this to you very simply. In fact, I'm not even going to use a pen and paper.
Newton's law of universal gravitation was known as the first great unification. It was the first time that anyone had correctly proposed a method that explained the relation between one of the fundamental forces on Earth with the behaviour of other astronomical bodies. The law states that every single particle attracts every other particle in our universe.
So there we have it, the law of gravitation. It states that two objects of mass will have an attractive force between them, and the sum of which is their mass multiplied by one another. Mass of the object 1 multiplied by mass of the object 2. And then you divide this by the distance between them squared, or their radius, and then multiply all of that by the gravitational constant. Everything you see around you has an attractive force to one another. I'm attracted to that tree. The larger a body of mass, the more attractive it is. But because of that constant right there, the force we feel is very small, and for good reason. That is the gravitational constant, and it has a value of 6.67 times 10 to the minus 11, which is incredibly small. It's because of this that you and I won't feel any force between us whatsoever. But on a larger scale, between planets and moons and stars, this comes into effect. It's only when we start to venture towards somewhere like a black hole when these laws break down. Everywhere else in the universe, this applies. But if you go somewhere like a black hole, it gets very mysterious. Now, another elegant equation that was explained later on by Newton's law of gravitation was Kepler's third law of planetary motion. It states that the period of a body squared is proportional to the distance it is from the primary body cubed. It's that simple, and it is incredibly elegant. It explained just how far bodies would be from the sun depending on how long their year was. And it led to calculations here on Earth that predicted planets further out in our solar system.
Building upon the workings of Kepler's third law was Bode's law, which correctly predicted the orbits of the dwarf planet Ceres and the gas giant Uranus.
What they realised when employing this equation is that they found a gap in between Mars and Jupiter. There should have been another body in between those two planets, but there wasn't. And astronomers searched and searched and searched for centuries in order to find out what was in the gap. And they found the likes of dwarf planets and large asteroids, but nothing that resembled a planet that should exist in the gap. And it wasn't until fairly recently that we realised this was where the asteroid belt was, the remnant of a much larger body. And the reason it no longer existed was because it sat in between Jupiter and the Sun at the right sort of point that meant it could never form a large body. The gravitational tugs of both Jupiter and the Sun meant that it never coalesced to form a planet like Earth, which means we now have millions of bits of debris, just like these pieces of snow flying around my face right now. Great.
For me, the first time in my life that I realised the true power of equations was when I was 15. I just finished playing football on a Sunday and decided on getting a 10-inch pizza for dinner like I normally would. But because I was so hungry, I wanted a bit more pizza, and rather than getting a 12-inch, I decided to get two 8-inch pizzas instead, thinking that this would be more pizza. But I was very wrong.
So, without thinking, I ordered two of these tiny little pizzas, which you can probably tell isn't quite as large as one 12-inch. But had I have known one very simple equation, I could have solved that without wasting my money. You see, all you have to know is the area of a circle. It's solved by multiplying pi by the radius squared. Now pi is 3.141599793234682644338327950284197169393937169399375110. In fact, it goes on infinitely, it goes on forever. But you don't really need to know the time 8 points, you just need to know up to 3.14. In fact, for this comparison, you don't need to know it at all. Next time you go to buy pizza and you want to figure out which one's the best value, all you need to know is the radius. So in this scenario, the radius of the 8-inch is 4 inches. That squared equals 16. The radius of 12-inch is 6. That squared is 36. 2 times 16 is 32 versus 36. There you go. So from that basic bit of math, you can tell that one 12-inch pizza has a larger surface area than two 8 inches. Two of these are £5 each, which means £10, whereas one of these is only £8. Basic bit of maths can save you a lot of money and get you lots of extra pizza. Now this next equation is a real cheat code of the universe. It's something that many of us believe is impossible to do. Something that only exists in science fiction. And that is time travel. But time travel is real, and you and I can both do it. I'm going to show you exactly how to, but first we need to understand a few conditions. We need to understand the laws of time travel. The first is that you can only travel forward in time. The arrow of time flows in one direction. You can't travel back in time, which means sadly for me, I can't travel back 20 years to when Arsenal used to be the best team in England.
Arsenal are the champions!
But what it does mean is I could travel forward 1 year to when Arsenal will once again be the best team in England. This is my twin, Mitch. Now I'm going to be moving very close to the speed of light, which means time for me is going to be ticking faster than it will for him. By the time we return, I will be younger than he is by almost exactly a year. Now I'm going to be standing here still for 365 days, whereas Mitch is going to be traveling very close to the speed of light, the speed limit of our universe. And in doing so, he's going to experience far less time than I will.
Now Mitch is going to be moving very close to the speed of light, which is impossible to do so on just 2 feet. But let's just imagine for the sake of this experiment that he can move that fast.
Here we go. Did we win? No. Oh, it got so much worse. How much worse can it get? You can take it from here. Now the reason Mitch has travelled forward in time is because he was moving very close to the speed of light, which is the speed limit of our universe. Now this equation states that the closer you are to that speed, the faster time moves for you relative to an observer. Now I have been the observer in this experiment, whereas Mitch has been the one moving. It doesn't matter how fast you move, if you have a velocity of any sort, then you are time travelling relative to an observer. Which means every time you go on a walk, a run, if you're in a car, bus, train, an airplane, you are time travelling. The only difference is you are doing it by such a small value that it is almost insignificant. You cannot notice this difference in time. We are talking on a scale of nanoseconds at the very best, which means if you were to be on a train moving at 200 miles per hour for your entire life, you wouldn't age much different to someone who was just sat at home for the entirety of their life. It's only when you go out into space and move at these tremendous speeds that time travel really becomes something that you can feel and notice. The second way to time travel is to be close to a significant body of mass, which we are. We are very close to the Earth, which means we experience a time dilation effect. In fact, if I stand on this, then compared to Mitch, I am experiencing time at a slower rate than he is. It is a very small difference. We are talking about a foot in difference. That's all it is. But time is now ticking faster for me than it is for him because he's closer to a body of mass, a very significant one. It's still on a scale where it is pretty much negligible. You cannot notice the effects of this. But because of this, your head is slightly older than your feet because of the difference. But it's so small, you cannot notice it. But if you go out to somewhere extraordinary in the universe, somewhere very special like a black hole, a place of incredible mass, then the effect of time dilation becomes very apparent to the point where you can practically stop time from your perspective. Now in school, you are taught a lot of equations, and it might seem like most of them, if not all of them, are completely meaningless. It might feel like once you've learned them at school, you know you're never going to use them ever again outside of the classroom. I know I felt the exact same myself, but that's not what's going on. What is happening at school is you are being taught the most essential and fundamental skill in life, and that is how to problem solve. Now the reason I call these the cheat codes of the universe is because they are some of the most fundamental laws in our universe. And most people don't fully understand how they work, but now you do. Now you can explore our cosmos to its deepest depths. The theory for time travel, all the maths around it, is solid. We've solved that part. The only issue missing now is the engineering. We don't currently understand how we can move that close to the speed of light. But maybe you could be the person who solves that problem. Maybe you could be the person who takes us to other solar systems, to other galaxies, to the very end of the universe itself. And you can do so because you now know the cheat codes of our universe. I'm Damon Scotting, and this was Astronomical.
Okay, so you may remember this spot from last week where I was filming and I got stuck in the mud. Well, today I was walking down the same field trying to get to the area where I want to film my final scene for Astronomical, like the season finale, and I got chased down by some cows. So now I tried to run down to this bank for shelter, and that did not work.
I've ripped my jeans. I have completely ripped my jeans. Oh no. You fucking melon. Oh, shit. Yeah, I have truly and completely, as well as being the biggest planet in the solar system, has the most amount of moons. Okay, hang on, let me wait for traffic to stop. Okay. Oh, f that bike. Let's try it again. Loud noises. How fast can we move? Now, that's an interesting question, and it depends on the way you look at it. As humans, we can move at speeds up to 45 kilometers per hour. And if you're wondering how fast that actually is, well, it's about this speed, but 2 times faster. Okay, that's just going to be one take, I ain't doing that again. But in terms of physics, the speed limit of our universe is about 300,000 kilometers per second. It just so happens to also be the speed of light. Now, there's many complications with traveling at that speed. Perhaps the main one is that the closer you approach the speed of light, the slower time moves from your perspective.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1.
I'm Damon Scotting, and this is Astronomical. The stars are just the beginning. Where does our universe end? Where does it begin? When we look up at our night sky, it seems impossible to count the number of stars. And yet our universe contains 33 billion times as many stars than we can see with the naked eye. The true extent of our cosmos is seemingly beyond the comprehension of any human. Out there are stars 2,000 times the size of our sun. Immense clouds of dust and gas, thousands of light years in diameter, in which new stars are being born. And there are black holes with a mass 66 billion times that of our star, more than most galaxies. These magnificent curiosities are amongst the few that we have discovered. And yet, as bizarre as they are nothing compared to the mysteries we are yet to unravel. The stars are just the beginning. I'm Damon Scotting, and this is Astronomical. Now, our long-distant ancestors depended on the stars for their very survival. They used certain constellations as a signal for the coming of winter. They alerted them to move on in search of food. Now, however, our relationship with the stars is pretty much non-existent. We don't depend on them in any way whatsoever. If you were to venture to a remote location, away from these dense city lights and the air pollution, then you'd likely see as many as 6,000 stars with the naked eye. But if you came to somewhere like here, central London, then you'd be lucky to see as many as 60 stars. But imagine how much differently we'd look at our lives if we could see as many stars as our long-distant ancestors or even the Greeks and Romans saw. These little problems that we get so worked up over wouldn't seem as important compared to the grand scale of the universe. So let's just imagine for a moment what London would look like without any air or light pollution. This is how London would look if you could just see the stars in the night sky. The Bortle scale is a way of ranking the night sky's brightness in a particular location. There are 9 levels,
with 1 being an excellent location with no pollution, allowing you to see the full cosmos, and 9 being the worst. Each year, more and more of our planet becomes a location where the Bortle scale is 9. But even at a high number, it doesn't mean you can't enjoy the stars in our night sky. My own back garden is a 6 on the Bortle scale, but I can still see plenty. Now for the majority of us, Orion is the most famous constellation there is. And that is largely in part because it's the most easily identifiable constellation in our night sky. In fact, I bet when you step out at night and look up at the stars, amongst the first ones you look for are the 3 that make up Orion's belt. The constellation itself is a sight to behold. It contains a rich variety of stars, red, white and blue. But even the ancient Greeks couldn't have possibly envisioned the wonders that lied just beyond our naked eye capabilities. Just below Orion's belt is its sword, and within that is the Great Orion Nebula. The Orion Nebula is effectively a stellar nursery. It's an immense cloud of dust and gas in which stars are born. For me, seeing the Orion Nebula for the first time through a telescope was a major turning point in my life. There are few things more majestic and magical than a colossal cloud of dust and gas in which stars are born. The idea itself is something even beyond what the Greeks may have imagined in their time, and yet it is true. And best of all, you can appreciate it in all of its glory with even the most basic telescope or pair of binoculars. In comparison to the Orion Nebula, our stellar neighbourhood is dwarfed, and this is just the beginning. Now, as brilliant of a sight as the Orion Nebula is, it is not alone in our night skies. In fact, with a standard telescope like this, you can see thousands of other nebulas. The nearest of which is just a bit further up to the left. Besides the first star that makes up Orion's belt, you can see the Horsehead Nebula. Now, the ancient Greeks were very imaginative with their stories. However, modern day astronomers are a bit more blunt when it comes to naming astronomical objects. They call it as they see it. The nebula looks like a horse's head, the Horsehead Nebula. Alongside it is the Flame Nebula. It is an emission nebula 12 light years wide. It's estimated to be a couple hundred of light years closer to us than the Horse's Head. Whereas the Horse's Head is a dark nebula. The thick dust blocks the light from behind it. It seems impossible to imagine it, as there really isn't much context, but this cloud of dust and gas in space is far larger than our entire solar system. A small reminder of the unbelievable vastness of our universe. Do you see that small cluster of stars just above my head? These are the Pleiades, otherwise known as the Seven Sisters. Now, the ancient Greeks had a lot of time on their hands back when there were no phones. And one of the things they enjoyed doing was creating constellations in which they connected the stars to one another in order to create stories. And amongst these stories was that of the Seven Sisters. The Seven Sisters were being pursued by Orion the Hunter. He followed them in a mad lust until Zeus heard their cries for help and cast them upon our night sky. Then, a few years later, when Orion the Hunter was killed by a scorpion, he himself took his place amongst the stars and is now seen every single winter in pursuit of the Seven Sisters. If you look just below the Pleiades, you'll see the constellation of Taurus the Bull, shaped a lot like a V. It's at the tip of this constellation that there is a remnant of a dead star that we can still see today. This is the Crab Nebula. The Crab Nebula went supernova almost 1,000 years ago in 1054 AD. And its explosive death was witnessed here on Earth by Chinese astronomers. They recorded it in their night sky and said the brightness lasted for 23 days. The supernova explosion was so bright that it could be seen during the daytime and appeared as a second sun. As they monitored the bright point of light over the next couple of weeks, they noticed its position in the sky did not change, which meant it could not be a comet. Imagine if they knew now what they were in fact looking at was the explosive death of a star 10 times the size of our own sun. Our Milky Way galaxy contains somewhere between 100 billion to 1 trillion stars. But what lies at the centre? Here in the galactic core, a massacre is taking place unlike any other. These are amongst the oldest stars in our universe. They were born just a few 100 million years after the Big Bang. And now they are being devoured by a supermassive black hole. The largest black hole that we know of has a mass 66 billion times that of our own sun, which is a ridiculous number. Black holes are incredibly dense, and at their centre is a point known as a singularity, which in itself is infinitely dense. It's difficult to analyse black holes because they swallow everything and anything. Nothing can escape their grasp, not even light. So it's because of this they are very hard to spot. The only way we can see them is when they interact with another body, by which point it might already be too late. There could be millions of black holes in our galaxy, just orbiting around with nothing to light them up. On average, in our galaxy, supernovas happen every 100 years. And yet we haven't had one for just over 300 years now, which means we are long overdue. There is a small chance that one of the stars in our night sky has already gone supernova, but the light hasn't had a chance yet to reach us. However, there are places in the universe where stars are packed so tightly together that they often collide. This is M13. One of the gems of our universe, or to be more specific, 700,000 gems. This is the Great Globular Cluster in Hercules. These stars are packed over 100 times more densely than our own stellar neighbourhood, which means they often collide with one another and produce new stars. If it was possible for life to survive in such a disruptive environment, then their night sky would look very different to ours, because theirs would be illuminated by starlight.
Now, although my garden is very good for looking at stars, it isn't perfect. In fact, on a Bortle scale, it is around 6, which still lets you see lots of stars, but there are ways to see more, and that is to get away from all the light and air pollution, which is what I've tried to do right now. I've come to what is the countryside near where I am, where the Bortle scale is 5. Not much lower, but it should be low enough to help me see some other targets. As you can see behind me, we have a full moon. Full moons can be a problem for when looking at stars, and that is because, much like other light, they pollute our skies. They limit the amount that we can see. So if you want to see as many stars as possible, you want to do so when the moon is not out. Most importantly, when it's not full. Even if it's at a crescent phase or about halfway through, you can still see many stars in the night sky. But when you get to this point where there's a full moon out and it's a lot higher in the sky, you will be lucky to see even the brightest stars. Now, just behind me is perhaps one of the greatest sights you can see with the naked eye. That fuzzy patch of light has changed the way we view our universe more than anything else in the history of mankind. It expanded our horizons further than anything else has ever done. It wasn't until the beginning of the 20th century that we really figured out what that fuzzy patch of light was. Up until that point, astronomers figured that that was a solar system in formation, but the truth was far more bewildering. It wasn't until Edwin Hubble was analysing Cepheid variable stars, stars which vary in size rapidly. Their diameter and temperature fluctuates, and from this you can determine how far away a star is. Now, whilst he was looking towards this fuzzy patch of light, he noticed about 12 Cepheid variable stars that seemed to be very far away. In fact, on average, the distance they were from here on Earth was 900,000 light years. Now, we know today that the Milky Way is about 100,000 light years in diameter. Back then, they estimated it was 300,000. But this meant that those stars did not belong to our galaxy. The stars we see around our night sky, these were the limit of our universe. This was all there was, or at least we thought all there was. But it turns out these didn't belong to our own galaxy. So where were they from? That fuzzy patch of light is the Andromeda galaxy. It's 2.5 million light years away, and it is the most distant point of light you can see with the naked eye. What Hubble discovered was another galaxy. Our universe didn't end with our galaxy. In fact, he realized soon after that there were plenty more galaxies out there, expanding our horizons further than anyone has ever done before or since.
The discovery that these faint nebulae in our night sky were actually entire galaxies was a game changer. Astronomers began to revisit old targets that had already been classified. We could see thousands of galaxies through our telescopes. But perhaps the biggest revelation came only 16 years ago, when Hubble captured something unbelievably special.
This is the most important image ever taken in our history. It is the Hubble Ultra Deep Field. It was achieved by the Hubble Space Telescope when it pointed towards a seemingly blank portion of the sky and took an exposure that lasted more than 11 days. Now, to us, this area seemed empty, but what it revealed was more than 10,000 galaxies. In this image, every point of light you see, all the distant tiny specks, aren't stars, they're entire galaxies. Supermassive collections of stars, hundreds of billions, maybe even trillions of stars, trillions of other solar systems. No other image has ever expanded our horizons quite like this before. No other image has ever made us feel so insignificant and small like this before. It is the most outstanding reminder that the stars really are just the beginning, and there is so much more out there for us to explore. I'm Damon Scotting, and this was Astronomical. you what, this water doesn't feel like salty or anything, that's cool. That has just went all down my jeans. Oh my god, my face stings. There is salt in that water. Times bigger than Everest. A storm big enough to engulf our world multiple times, and a moon with more volcanoes than the whole of Earth. These are just a few of the Ninu Ninus. That's what I get for filming in London. Okay, now the final question is one that's been popping up a lot recently. It's a question that people have asked for millennia. Is the Earth flat? Now, in order to explain why the Earth isn't flat, I'm going to need more than 10 minutes. So I'm just going to run quickly through some of the main reasons why we know the Earth isn't flat. Number one, the night sky. Here in the Northern Hemisphere, I see some very different stars to those down in the Southern Hemisphere. And that could only happen if we were on a sphere rather than a flat plane. Seasons, the Earth has a 23-degree axial tilt. Wouldn't happen if we were flat. The water on our surface, how does it stay here? It wouldn't do so on a flat surface, it would fall straight off, but on a sphere, or an obloid, it is tightly bound to the surface by gravity. And that's another thing, gravity. How do we have an even distribution of gravity on a flat object? Doesn't happen, basic physics. What about the rest of the planets? How come when we look for our telescopes we see them as disc shapes? Or how come if I stare through my telescope long enough at a planet, say Jupiter, I notice it rotates on an axis, meaning it must be a sphere? What if I went to the seaside and watched the ship pass off into the distance? Number one, why can't I see the Burj Khalifa whilst looking out to the distance? If the Earth was flat, I'd be able to see the world's tallest tower and everything else around me. What about the ship passing off in the distance? How come when it disappears from our point of view, it does so by tilting up its backside? Well, it does so because the Earth is a sphere. The Earth isn't flat, and to say so is not only ignorant, it's arrogant, and it's promoting bad science. Don't listen to people who promote bad science. I'm Damon Scotting, and this was Astronomical.
Nine, 8, 7, 6, 5, 4, 3, 2, 1.
I'm Damon Scotting, and this is Astronomical. Life is a competition. Everyone is fighting for the right to survive. And I don't just mean humans, I mean all forms of life on our planet. The Earth and its environments vary and change rapidly, so in order to survive, you need to be willing to adapt to your environment. In this episode, we're going to answer the question, why only the fittest survive? I'm Damon Scotting, and this is Astronomical.
The first thing we need to understand is where did life on our planet come from? This is the birth of our solar system. Within this supermassive cloud of dust and gas are hundreds of stars being born. Our sun is a second or third generation star, which means we are formed from the ashes of another much larger star, whose supernova remnants are now the seeds for new, smaller stars, which will live for much longer than they did. Certain areas of the nebula start to condense and produce protostars, which are still surrounded by large amounts of debris. As time passes, order begins to take hold. Some objects are orbiting in the opposite direction to the majority of others. They eventually collide, and the young solar system develops a sense of direction. This is why you tend to see almost all of the celestial bodies orbiting anti-clockwise around our sun, because if they didn't orbit in the same direction, they would crash into one another. This stage in the life of our solar system was exceedingly violent. This is the Earth colliding with hypothesized planet Theia. The collision produces an immense amount of debris which slowly coalesces in its orbit around the Earth to form our moon. The moon becomes tidally locked with the Earth and gives us a steady rotation on our axis. Now, our planet was ready to become the blue planet. After a couple 100 million years, it had finally cooled enough to allow the first appearance of liquid water. We now move into the late heavy bombardment, a period in which the Earth is being attacked by countless impact events. It is likely that the thermal flux led to hydrothermal activity. Here at the bottom of our oceans, they produce the first signs of life. Our next best theory is that one of those pesky asteroids that rain down on the planet contained the ingredients for life, which under the right conditions flourished. Either way, almost 1 billion years later, photosynthesizing cyanobacteria evolves and triggers the Great Oxidation Event, leading to the oxygen concentration in our atmosphere to rise. This is when things really start to get interesting. Simple life gradually becomes more and more complex, as we see the emergence of sponges, jellyfish, and eventually crustaceans. As the fish begin to take control of the seas, one brave animal decided it had seen enough of the water and wanted to conquer the potential niche environment that was the land.
This is Tiktaalik. It was the first vertebrate animal to venture from the oceans onto the land, which means it was the first backboned animal to take advantage of all the food that was out here on the surface. Because it made this transformation of environment, we are here today. Every species outside of the fish and insects has evolved from this creature. Now, as you can probably tell, although it does look very much like a fish, its fins have become limbs. These allowed it to move across the surface of the ocean floor. It would venture from lagoons like this to one another in search of new food. But whilst it did so, it made the trip across short stretches of land. And it discovered that there was a vast variety of different food sources here on land. Because of what Tiktaalik did 375 million years ago, we are all here today.
From the amphibians evolved the reptiles, in which the dinosaurs were a very big part of. It was almost 200 million years ago that marked the beginning of the golden age for the dinosaurs. They ruled the planet unchallenged. Amongst them were a group of dinosaurs known as theropods, which included some very special members, like velociraptors, the Tyrannosaurus rex, and one very particular dinosaur that changed the Earth forever.
This is the most important fossil in the history of science. It is the missing link. It belongs to an animal named Archaeopteryx. Now, the reason Archaeopteryx was so special was because it was half reptile and half bird. Its fossil shows that it had feathers, and this is special for one of two reasons. The first being that reptiles are cold-blooded animals, which means they need the heat from the sun in order to survive, but feathers conserve heat. They also allow for powered flight. There was enough muscle on the bones of Archaeopteryx to allow it powered flight. This wasn't an animal that just coasted through thermal pockets of air. This was an animal that flew. This is a transitional fossil. Archaeopteryx was at an intermediate stage. It overlapped between reptiles and birds, but it bridged the gap between these two. The discovery of Archaeopteryx was concrete proof of evolution. But it came 2 years after Charles Darwin published On the Origin of Species. So what inspired him? Well, it all started when he was 22 years old and he ventured to the Galapagos Islands. This is the Galapagos Islands, a volcanic archipelago 1,000 kilometers off the coast of Ecuador. It was here that a 22-year-old Charles Darwin first developed his theory of evolution. And it's because there are few places on Earth that are more diverse and abundant in forms of life. As you can probably tell, the Galapagos Islands is several complex, varying environments. Some have volcanoes that are freshly erupted, whereas others have volcanoes that have been dormant. What that means is, on the islands where volcanoes have just erupted, the soil is very fresh, very fertile, whereas the ones where it's been dormant, it is dry and almost barren, meaning that different forms of life have had to evolve with their environment, especially if they are limited to just that island. Now, many people believe that Charles Darwin formulated his theory of evolution based on the finches from the Galapagos Islands. But although they played a huge role, this isn't necessarily true. Arguably, the biggest factor in his theory was the tortoises. The Galapagos tortoise was amongst the biggest in the world. In fact, the name of the island comes from a Spanish word for tortoise, Galapago. These weighed up to 250 kilograms and were as much as 5 feet long. They were enormous. And whilst the sailors set off for the rest of their expedition, the tortoise proved very useful. They needed a food source, and these provided plenty. They had a very slow metabolism, they could sleep for 16 hours a day, and they didn't need to drink or eat for up to a year. But what Charles Darwin noticed was that the tortoises tend to have two very distinct shell shapes. For most of them, their shell shape was flat, but others had one that was more concaved, allowing their neck to venture higher from the ground. And this was because of the island they belonged to. If the island was barren and there were no food sources on the ground such as grass, then they needed to look for other food sources, and that could be leaves off branches. Now, there were obviously other forms of life on the island, which would have likely picked off the same food sources the tortoise had. But they evolved to make the most of different food sources, ones that were inaccessible to different forms of life. They had evolved and adapted with their environment.
The tortoise evolved from the turtle, which came to exist around about the same time as the dinosaur. But today, we still see species of turtles in abundance. So what happened to the dinosaurs? Sometimes in life, you can do everything right in order to survive. But that doesn't mean you can stop an asteroid impact from wiping out roughly 75% of all life on the planet. The asteroid was roughly the size of London, and it practically decimated the entire animal kingdom. The non-avian dinosaurs that were over 25 kg did not survive. The aftermath of the explosion blanketed the planet in a fiery cloud of dust, suffocating most species and rendering them extinct. But amongst this catastrophe were a small number of ground dwellers. These were amongst the very first mammals. Nocturnal animals that scurried around the ground at night in fear of the dinosaurs. Their time had now come, as the earth was up for grabs. With no real threats other than each other, the land was a free kingdom, one which those early mammals took control of. With the ground no longer being their limit, some species decided to take to the trees in search of more food. These were some of the very first primates. We are primates. We belong to this family of animals. There are several key moments during history where our family tree branched off, leading to a variety of different primates that are essentially our cousins. Here in the Amazon jungle live what are known as the New World monkeys. They branched off from our family line roughly 45 million years ago. But despite there being almost 50 years of evolution between us, we still share a striking number of similarities. Amongst the key factors are the two forward-facing eyes. This is a pygmy marmoset. Weighing ever so slightly more than 100 grams, they generally live in troops of between 2 to 9. In fact, some of our long-distant primate cousins still share a striking resemblance to us today.
This is a red wakari.
A red wakari.
The local people here, they call England monkey. By the way.
We can trace our ancestry all the way back to the Tarsian, which is an animal that resembles the pygmy marmoset in many ways. Its separation was soon followed by the New World monkeys, and then the Old World. In evolutionary terms, it wasn't until fairly recently that we branched off from the other great apes. Firstly the orangutans, then gorillas, followed by the chimpanzees, and then finally us humans. We still had to go through many different steps amongst the Homo family. Homo habilis, Homo erectus and the Neanderthals are all now extinct. But they did all show one key striking difference between their skulls, and that was that they were gradually allowing more room for a bigger brain. We have now reached the Holocene. All archaic humans are now extinct.
Now, it wasn't until 11,700 years ago that we were still in an ice age. Most of the planet was very similar to this. It was very cold, which meant that in order to survive, you had to adapt to a different environment, which many species did for millions of years. Change happens rapidly, and it always happens. We've been through many ice ages. In fact, we're due another one around about now. So those species that couldn't adapt to the melting temperatures which caused most of the ice to disappear, they went extinct. And one of them was a truly colossal animal that was pretty crucial to the survival of our species. This was the woolly mammoth.
The woolly mammoth was vital for human survival. We used its fur for keeping us warm, as well as its tusks for creating tools and shelter.
Now, the woolly mammoth was a colossal creature, but its extinction lined up with the end of the last ice age. This was an animal specially adapted to suit the cold environment. Its short, fluffy ears and tail were brilliant at conserving heat. But as the ice began to melt, this phenomenal beast couldn't stand the warming temperatures and lack of surface. Now our planet is covered in 70% water, when back then during the Ice Age it was pretty much all solid ice. And around about this same time, when the mammoths went extinct, Max, come here, another drastic change occurred. Over 10,000 years ago, Max's great ancestor was one of the most feared creatures on our planet. Now, a very special relationship occurred between humans and wolves. Much like humans, wolves are pack animals. They hunt together. This is because there is safety in numbers, and you're more likely to get a meal at the end of the day if you hunt together rather than solo. But some of the wolves that were outcasted became very desperate for a meal. They felt that they needed to find any scraps possible, which led them to the early humans. When they were finished with a kill, they left behind the scraps, the bones with a tiny bit of meat on them. The wolf would wait patiently, posing no threat. In fact, often acting as a guard, protecting them from any other predators that might come and try and feast on their meal. And it's because of this that the humans continue to give these wolves a steady meal, which meant they survived and passed on their genetic code to future generations. This led to future generations of more tame, docile, and trusting wolves. Pretty soon, a partnership developed between humans and wolves. Now the humans and wolves would hunt together, and this was an alliance that led to both parties prospering. It wasn't long after that we developed agriculture, which meant we could count the amount of things we had. We got to a point where we had more stuff than we needed. So our focus was no longer on looking for the kill for the day, finding the next meal. We could focus on other things, which meant wolves were no longer bred just for their hunting ability. Instead, we chose to breed them for other traits. Perhaps they had fluffier ears, maybe they were smaller, maybe they had a much more high-pitched yelp rather than a roar. The transformation of the wolves became so dramatic. In just over 10,000 years, the wolf has turned into what we know as today as the Chihuahua, which is, if anything, more fearsome than the wolf. Max here is a result of selective breeding. We chose to breed his ancestors with one another based on certain appearances. Now he is a lot smaller than a wolf. His fur isn't quite as thick and insulating. His ears bend and flop down the perfect amount, and the colour is different to the rest of his body. The shape of his face, all of this is determined by humans. Now, in today's world, dogs cover every corner of our planet, every inch of the planet. You can't go anywhere in the world and not find a dog. And that is a result of humans. Our choice to selectively breed these animals has changed the face of our planet forever. Now, when Charles Darwin said, "Only the fittest survive," he didn't necessarily mean the strongest. He used it as the Old English term. Those that fit their environment the best are more likely to survive. And it's because of this that the world is full of countless, diverse and incredible species, all of which are specially adapted to their environment. It's because of evolution that the world is such a beautiful place. I'm Damon Scotting, and this was Astronomical. I'm just going to say this as what it is, a fucking disaster. I don't remember what I was talking about. Space. There's a collection of several 100,000 stars that are densely packed together. So dense, in fact, that our diameter... Fuck. Okay, let's go again. And there will be nothing left but the vacuum of space. That if anyone is left to see this wonder occur, it will truly be a sight to behold. Okay, damn it, 3, 2, 1. What is at the centre of our galaxy? Well, it's the same thing that is at the centre of most galaxies. One of the biggest mysteries facing science today. This is a black hole. Now, black holes are incredibly curious objects. We know very little about them. We know they're incredibly dense, which means they have a small volume or size, but a very large mass. What we also know is that at the centre of a black hole is a point of infinite density known as a singularity. Which means, if you get close enough to a black hole, there'll eventually be a region in which the gravitational pull is so strong that nothing can escape it. Not even the fastest thing in a universe, light. So what would it be like to fall into a black hole? Well, you'd be stretched from toe to head at a speed of light in a process known as spaghettification. And if you want to know what it's like at the centre of a black hole, you've got a very slim chance, because your atoms will be ripped apart individually. This is perhaps one of the most exciting prospects in science. Maybe we will never know what lies at the centre of our galaxy, because we will never know what lies at the centre of a black hole.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
I'm Damon Scotting, and this is Astronomical.
This is the moment that changed everything. This is the most important moment in the history of the human race. It is when we left footprints on another world for the first time, but by no means the last. I'm Damon Scotting, and this is Astronomical. This is the Apollo 11 landing site. This scene right here was taken moments after Buzz Aldrin joined Neil Armstrong on the surface of the moon. These two men etched their names into history by becoming the first two humans to set foot on another world. But there was a third astronaut aboard this mission. His name was Michael Collins. He's become known as the Forgotten Astronaut, and yet his role was equally instrumental. Whilst Neil and Buzz were doing the legwork on the surface of the moon, he was in orbit, awaiting their return. And during every orbit, he would spend 48 minutes on the far side of the moon, unable to communicate with not only everyone back on Earth, but also Neil and Buzz. He was the loneliest man in the universe for those brief periods. In fact, when Neil and Buzz actually landed on the surface of the moon, he was unable to communicate with anyone. He was not aware that they had been successful, which would have been a major concern. Around his neck, he carried 18 contingency plans. These were necessary in case the mission would fail, in case Neil and Buzz wouldn't be able to return from the surface. This brought him a great deal of stress. In fact, President Richard Nixon even prepared a speech to give in case Neil and Buzz didn't make it back. The mission to go to the moon was unprecedented. It had never been attempted before. The moon on average is 384,000 kilometers away from the Earth, which, to put that into context for you, is the same as going around our entire planet 7.5 times. And that's just one way. They've still got to come back again, and that is no easy feat. If anything, that is harder. And the journey would have been even more difficult if Michael Collins had to make it back alone. The bravery, determination and courage these three men shared was unparalleled, unmatched, but we're going to need plenty more humans like them in the near future, because the moon is just the beginning. This is how Mars may look in 50 years' time. Our plans to colonise the red planet are nothing new. In fact, when the Apollo missions ended, many people believed that in the next 50 years we would have colonised Mars. And as you can probably tell, we are nowhere near reaching Mars, or at least a human setting foot on the red planet. We have sent many rovers there in attempts to analyse if it is suitable for us to live on. But as we know, Mars isn't very hospitable. The temperatures on Mars are a lot colder than they are here on Earth. There is much more carbon dioxide in the atmosphere. The gravity is less than half of that here on Earth, meaning it's not ideal. But we can make it habitable. We can change the composition of the atmosphere to make it a world in which we can live on. The trip to Mars is not an easy one. Going to the moon takes 2, maybe even 3 days to get there. But Mars, at its closest point to Earth, takes 8 months. And that is just one way. And I say that because it's likely that a trip to Mars will be just one way. It's very expensive to get there, it's even more expensive to come back. So those brave adventurers that are going to be the first people to walk on the surface of Mars will also die there. Perhaps that is the cost of exploration. That is the price you must pay to boldly go where no one has ever gone before. But if we create a world like this, in which they can live peacefully, carry out plenty of research which will be vital for future generations, then it will be well worth it. But arguably one of the biggest hurdles to overcome is chemistry between inhabitants. If you have an argument with one of your crewmates, you can't go outside and go for a long walk and just forget about the situation. You are going to be together for long periods of time in very close quarters, perhaps for the rest of your life, which can be very stressful. And the first people to go will be very expensive liabilities. It is no easy feat. There are plenty of missions being carried out here on Earth where they take isolated groups and put them together for years on end and see how well they fare in such close quarters with one another. Today it is a question of whether or not to send humans to Mars. We have the technology to do so, but there are still plenty of things holding us back. One thing is for certain though, and that is that the first person to walk on Mars is alive today. They may even be watching this video. To many of us, Mars is our best chance of finding life elsewhere in the solar system. Or at least it was. Out there, in the depths of our solar system, there are other worlds that may contain life. Not planets, moons. Moons that orbit around the gas giants. These are some of the most extraordinary worlds that we have ever discovered. And they hold plenty of potential for life. Do you see that moon just there? That is Io. It is the most volcanic world in our solar system. It is a hellish landscape, but even there may exist life. It makes up one of the 4 Galilean moons, all of which are potentially habitable. We could one day colonize those moons. We could live on them. Now this far out, the moons and the planet itself are very cold. They don't receive much heat from the sun. But how is it these moons are able to have the potential for life? Well, it's all due to their orbit around their planet. Rather than orbiting in a perfect circle, they move around in what is known as an eclipse, which is a slightly squashed circle. And it's because of this, there are points where they're closer and further away to their planet, which means they feel a stronger and weaker gravitational pull. This stress and tension on the core of the planet causes it to heat up. It's also why one of the other moons, Europa, is capable of harbouring more liquid water beneath its frozen surface than there is on all of Earth. One day we will go fishing on the surface of Europa, and we may indeed find life. There is potential for life beneath the frozen surface. It is isolated from the harsh environment of space. And Europa isn't the only frozen world in our solar system that's capable of supporting life. Orbiting around Saturn is a tiny moon known as Enceladus. It is responsible for Saturn's most outer ring. But because its gravity is so weak, it cannot hold on to the water. It immediately freezes as it leaves the geysers. It exits the atmosphere, meaning as Enceladus orbits around Saturn, it leaves a trail of these ice particles, and they produce Saturn's most outer ring, Saturn's E ring. The geysers are proof that Enceladus has a warm core, and you can see at the south pole these tiger stripes. This is a very, very high potential for life elsewhere in our solar system. Beneath the frozen surface, life would be protected from the external environment of space. The very harsh vacuum and ultraviolet rays, none of that would affect life beneath the surface of this world. And as special as our solar system is, it is still just the beginning. There are plenty of other solar systems out there, each with a limitless potential for life. Some of which, though, will look very different to our own solar system. This is a more common sight than you may think. Two suns setting below the horizon is something that seems like it's straight out of science fiction. But a planet belonging to a star system that has two or more stars, a binary star system, is more common than singular star systems. Which means our star system is fairly unique. Our planet, its distance from the Sun varies very little during its orbit, perhaps 2 million kilometers. But if you were to orbit around two different suns, then your orbit would be chaotic. It wouldn't be as straightforward as going in a slightly squashed circle around your star. It would be chaos. It's likely that one star will be much larger than the other star. So your orbit will be based on the larger star, but also influenced ever so slightly by the smaller star. The temperatures between the two stars could also vary dramatically. One might be very hot, one might be very cold, which again means the temperatures that you feel on the surface of your planet would fluctuate rapidly. So where in our universe might there be stable conditions for life to thrive? Our Sun will die in 5 billion years. It's going to swell into a red giant as it reaches the end of its lifetime and possibly engulf our planet, burning it to a crisp, eliminating all forms of life on the surface. But there are stars out there that live for far longer than 10 billion years. Some that live for as long as trillions of years. These are red dwarfs, and they're amongst the most abundant stars in our universe. If they are a singular star system, like our Sun, then they have plenty of potential for life. One of the best chances for finding life outside of our solar system is in the TRAPPIST-1 star system. This is a star that contains plenty of candidates for life. This is the TRAPPIST-1 system. These are the planets that orbit around this tiny little star. And the reason this system is so special is because normally we find it very rare to see a planet orbiting around a star that exists in the habitable region, meaning it could potentially harbour life on its surface. But this system has several planets that exist in the Goldilocks zone, where it's not too hot and not too cold. And they're all very similar in size to the Earth, Venus, Mars and Mercury. Each one of these planets has the potential for life. The star system itself isn't very far away. You can see it in the constellation of Aquarius. It's about 40 light years from us. This ultra cool red dwarf is barely larger than Jupiter, but it has a mass over 80 times that of the gas giant. Unfortunately, we have no way of viewing what these planets really look like. Planets do not emit light, so when we look out for these exoplanets, we have to analyse the light from their star. By monitoring its brightness, we can determine the size of a planet as well as its orbital period. We are also able to see the composition of a planet's atmosphere by measuring the spectroscopy of the light as it passes through the planet. We can then subtract this from the light's normal rays and determine whether or not it is capable of supporting life. In 2018, researchers determined that planet E was the most likely out of all of the planets to be an Earth-like world. It could be covered in oceans of water, making it an excellent candidate for future habitation. Because of the star's small size and low temperatures, planets can afford to orbit a lot closer. This entire solar system would fit well within the orbit of Mercury. But being so close puts the planet at a high risk of being greatly affected by the radiation of solar eruptions. Because of the planet's close proximity to one another, if life were to develop on any one of them, it is extremely likely that it would spread to the others too. This means that there may exist life on not just one, but multiple worlds. This means that one day we will explore this system. There may be life awaiting on the surface for us. It may be advanced life that we one day communicate with. It may be simple life. This may one day become another home for our species. The technology to visit these new worlds is here today. We are capable of visiting the moon. We are able to visit Mars. We've even ventured to the very edge of our solar system. What we now need are individuals with the right amount of courage and determination and desire to explore. Individuals that enjoy these types of videos because they are interested in seeking the wonders out there. And when they do, they will make one big step for mankind. I'm Damon Scotting, and this was Astronomical.
Who was the last person to set foot on the moon? Well, that title has belonged to the same person for the past 50 years. His name is Gene Cernan. However, he himself is not very proud of that title. And that's for the simple reason that when the Apollo missions were happening, the interest in space exploration was at an all-time high.
We choose to go to the
People
moon.
wanted to see people on the moon, on Mars, on different worlds. But after his final Apollo mission, Apollo 17, no one has left any more footprints on the moon. And that's because the space race was over. America had won and beat Russia, and there was no more funding towards space exploration. By now, he would have probably expected us to have a base on the moon, maybe even a base on Mars, but that simply hasn't happened. Who knows, maybe in the next 50 years, we will have more footprints, not just on the moon, but on Mars and other worlds.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1.
I'm Damon Scotting, and this is Astronomical. At one point in your life, you're going to ask yourself the question, what is the meaning of it? What's the point? And you're going to think about that question long and hard until you find an answer that satisfies you. Some people believe they've found the answer to that question, and others may spend their entire lifetime searching for one that gives their life purpose. In fact, they may never find it. So in today's episode, we're going to try and answer the question, what is the meaning of life? I'm Damon Scotting, and this is the Season 2 finale of Astronomical.
So, in order to answer the question, what is the meaning of life, we need to look back to how life first began. which means we need to go back 13.78 billion years to the beginning of our universe, the Big Bang. The Big Bang wasn't an explosion as per se, it was the beginning of space and time itself. Everything you see around you, all matter, originated from the Big Bang. You, me, the bees, the trees, everything came from this singularity. A point of infinite density that expanded faster than the speed of light and cooled rapidly. The universe began to cool and eventually formed the very first stars, which would go on to form galaxies much like our very own Milky Way. Now, although we can't tell what came immediately before the Big Bang, we do have a good idea of how our universe started. We also have a good idea of how it may end. And that could be through one of three different ways. You have the Big Freeze, the Big Rip, and the Big Bounce. All of these scenarios depend on the density of our universe. The Big Freeze in this scenario is where the universe continues to expand at an accelerating rate. All of the stars exhaust their fuel and eventually die out. In fact, even black holes slowly evaporate through Hawking radiation. And eventually the universe reaches a state of maximum entropy, where nothing happens and nothing keeps happening forever. Time eventually becomes meaningless. Or the universe could end in a scenario known as the Big Rip. In this case, the universe continues to expand at an ever-accelerating rate into the point where not only are galaxies and solar systems ripped apart, but subatomic particles are. Nothing will remain in our galaxy. A very brutal end. And then finally, we have the Big Bounce. Now in this case, the universe doesn't continue to expand. Instead, it contracts in on itself. So whereas we began with the Big Bang, and slowly after time, stars began to form and galaxies. When the universe contracts in on itself, all of this will begin to coalesce until eventually we reach a point of infinite density, a singularity, which could lead to the birth of a new universe. And in this cyclic model, universes continue to oscillate between birth and death over and over again, perhaps forever. Now, out of these three scenarios, perhaps the Big Bounce is the most comforting. And I say that because there is a definitive end. With the others, we wouldn't be around to see how the universe did end. But speaking of which, we ourselves will not be around to see how the universe ends. Our lifetimes are very short compared to the scale of the universe. Which means the question, what is the meaning of life, has to be more personal for us. If we want an answer that applies to us independently rather than the species of human, we need to look on a much smaller scale. So now we're going to explore three different schools of thought. These are three of the most popular outlooks and answers to the question, what is the meaning of life? We have the humanists, religion, existential nihilism. Humanists believe that we have the right and responsibility to shape our own lives. Together we derive a moral code from the lessons of history, our personal experiences, and our own thoughts. Science provides us with the only knowledge there is about our universe, and that knowledge says that this is our only life. There is no afterlife, and there is no reincarnation. This is all there is. They believe that we each make our own independent choices that shape our life. There is no influence from supernatural beings, which means the personal relations we make as humans are important and crucial towards the happiness of humanity. For a humanist, the bottom line is essentially that you are in charge of your own happiness and are free to determine what you think is the meaning of life. Now, there are many different religious viewpoints towards what is the meaning of life, but they all seem to have a very similar basis, and that is that there is a God or gods, a creator, a supernatural being who produced everything we see around us and gave us life. and to them we should be grateful and appreciative of what they have produced. Some religions believe that your actions here on earth are a test for where you will go in your next life, whether it be the afterlife or reincarnation. They believe that our main purpose here on earth is to contribute to the well-being and spirit of others. And by showing a strong devotion to God, we will follow a path that is more enlightened. Your purpose here on earth is to serve humankind, to prepare to meet and become more like God, to choose good over evil, and ultimately have joy. Oh, is it me now? Okay, it's me. Existential nihilism. So, this is based on the belief that there is no supernatural being that determines the essence of our life, and life has no meaning. It is up to us to decide for ourselves if there is any purpose to life by setting goals that inspire us. The universe is a huge place, and we are not at the centre of it. The stars in the night sky, they do not twinkle for us. The immense scale of the cosmos is unimaginable. We cannot comprehend it, and it is surely not built for us and us alone. Our lives are completely meaningless, and you will soon be forgotten. Collectively, we are insignificant specks of dust floating around aimlessly in a distant remote corner of our universe as it continues to expand at an ever-accelerating rate, meaning we are all devoid of any meaning. Holy f***. Are you okay? Do you need a hug? Oh my god. Well, it's the truth, innit? Holy sh**. So, to summarise, you decide the meaning of life.
God gives your life meaning.
There is no meaning to life. Now, each of those groups raise a number of interesting points, which makes it difficult to assign yourself to just one of them. You may not believe in devoting your life to God, but you might agree that there is a God. The universe surely needed a creator. Yes, the universe is huge, and our actions seem inconsequential in the grand scheme of things, but that doesn't mean we can't find a purpose for our lives, even if that purpose is simply to make the lives of others better. In terms of one-lined, definitive solutions to the question, what is the meaning of life? Here are 8 of the most popular answers.
The first one is, the meaning of life is to live forever or die trying. The goal of every cell is to become 2 cells. To become the best version of yourself. To seek wisdom, avoid suffering by ignorance, and above all else, find happiness. To leave the world in a better place than you found it. To devote your life to God or the Creator. They have given you life here on earth. To become the best version of yourself. Life has no meaning. Our existence occurred by random chance, and anything that occurs by chance has no purpose or meaning in our universe. And then finally, the last answer is that the answer to the meaning of life is too profound for us to understand. You will never live a full life if you spend it seeking an answer to a question you will never fully understand. In about 60 seconds' time, something very special is going to appear in our night sky. Something that up until 2 years ago, no one had ever seen before. A sight that would have sent our ancestors crazy. It might look like the beginning of the end, but is actually just the beginning of a much brighter future. Here we go.
These tiny bright lights in the night sky are not stars, planes or planets. They are satellites. Passing overhead are 60 of the Starlink satellites, which will go on to form a constellation that surrounds our planet. Ultimately, these satellites will work together in order to provide you with internet anywhere on the planet. It doesn't matter whether you're in the middle of a city or if you're in the middle of a desert. you will be connected anywhere on our planet. The launch of these satellites marks the beginning of a new golden age of information. One that knows no limits or boundaries. Knowledge is now accessible to anyone and everyone. We are now more connected than ever, and yet for some of us, we feel at our loneliest. For the vast majority of us, the meaning of life is derived from the personal relations we have with others. The last year has put a seemingly relentless strain on that connection. Our only window to the rest of the world has been through the internet, which has led to cases of loneliness rising more and more. In these dire situations, people find themselves now more than ever asking the question, what really is the meaning of life?
From a biological standpoint, our purpose in life is simply to reproduce, to spread across as much of our environment as possible, which we are very good at. There isn't an area on our planet which we are yet to colonize. Even the most inhospitable places like Antarctica have seen humans born and raised there. By default, we are not supposed to be happy. A state of contentment is discouraged because it makes us vulnerable to predators. Human beings are very social creatures. We are only here where we are today because our ancestors worked together to survive. It's the relationships we make in life that give our life meaning and purpose. And that is why loneliness is so toxic and it kills twice as many people as obesity does. There is no definitive answer to the question, what is the meaning of life? And that's because it varies so dramatically depending on the scale at which you try and answer the question. If you try and answer it on the scale of our cosmos, then you simply don't have enough information. We haven't explored enough of our universe to answer why it's here and what its purpose is. But if you turn to that question on the scale of our species, then we know that our purpose is to reproduce and colonize as much of our universe as possible. And then finally, on the scale of humans, the answer can be found through relations we make with other people. The answer to the meaning of life is love. Love what you do. Love the people around you, and then you will love the life that you live. By making others happy, we make ourselves happy, and vice versa. It is only by working together that we stand a chance of figuring out what a definitive answer to the meaning of life may be. Answering the question, what is the meaning of life, on the basis of our lifetimes means that there is no right answer, because we simply don't have enough information to correctly answer the question. But it also means that there is no wrong answer. It is up to you to choose what your purpose is. For me, the purpose of my life for the last 6 years has been to make this documentary, which I can happily now say has succeeded. I've done it. But it didn't seem like it was ever going to happen. It wasn't until 4 years ago that I recorded the first piece for Astronomical. And even then, it wasn't in front of a video camera because I was too shy. It was just a voice note of me talking about Jupiter and its moons. And I can say now in hindsight that that voice note was awful. It was absolutely horrendous. It's a bit like when you sing along to a song and you think you sound pretty good, so you then record your voice separately without any music and listen back to it, and then you realise you can't sing at all.
Fly me to the moon, let me play among the stars.
Everything I was saying was completely rushed. I was stuttering a lot. I was really nervous, even though it was just me talking to my phone. No one else was going to see it at that point. It was just for me, and yet it sounded awful. I was yet to step in front of a camera, and I couldn't get this part right. So I continued practicing over and over again.
The solution was to just keep talking to camera until it felt completely natural. Eventually, I didn't feel any pressure or nerves, and my voice stopped being so shaky. So 3 years ago, I decided it was finally time to start filming the documentary. I knew that in order for this documentary to be gripping, I had to make it visually appealing, so the viewers would stay tuned in for longer than if I was just talking in front of a whiteboard. I planned a solo trip across Europe, in which I would visit some spectacular landscapes. The first on my list was a place known as Lake Bled in Slovenia, I had already prepared the shooting locations at home using Google Maps, I had recited the scripts to memory, all that was left now was to go out and record it. But regardless of how much you plan, there are still things you cannot anticipate for. One of those things is that a group of 40 Chinese tourists arrive the moment you start recording, and as well as taking photos of the castle that have you in it, they also take images of just you, which doesn't exactly do wonders for your self-confidence. Alongside this, the lighting and sound quality were awful, but I didn't notice this until I got back to the hotel room. It was only once I got back to the hotel that I realised I couldn't do this alone. I needed someone to help me out, to tell me if things didn't look great or if it sounded awful. So I headed back home having learnt a lot. I still hadn't told anyone about the documentary. I wanted to make it first and then show people. But then on a Friday night at the casino, I told my best friend Sachin about what I was trying to do, and he couldn't have been more supportive. Over the next year, we drew up plans to travel across the Americas and film this documentary. During this time, I was still studying astrophysics and cosmology at university full time. But in order to afford these trips, I took a full-time job at the National Space Center, which was one of the hardest things I've ever had to do. I was doing just enough to scrape by in terms of grades until day one of our trip to the Americas. Whilst waiting to board our plane, Sachin read out my grades, which said I'd failed one of my modules.
Physics 4, 18 MAC 108, score 36.
I did retake it after the trip and pass, but it wasn't the best way to start this adventure. Already, the benefits of having someone to help make the documentary were apparent. The stress of travelling was greatly reduced.
Lentil. You don't know what a lentil is? Come on. You know pie. You know pie. You don't know what a lentil is. No. Lentils like... that's a lentil. They're lentils.
We got the footage we needed at the destinations we wanted it to be filmed at, but still something wasn't right. 7 wonders of the world, alongside the likes of the Colosseum, Great Pyramids of Giza, and Chichen Itza. This is Machu Picchu.
Oh.
I'm so hungry.
What do you say? Machu Picchu, yeah.
The majority of the footage was rushed. We only ever spent a couple of days in the country, and then only a few hours where we wanted to film.
Blackjack.
I had 2 weeks off from work and university. I was leaving the day after an assignment hand-in. Although we had been playing this for a while, it felt like it was coming and going too quickly. Once we got back from the trip, I looked over the footage and I realised, much like the Europe trip, I had barely got anywhere near enough footage to make a documentary. Something had to change. I was still determined to make the documentary though, it still felt like this was my purpose. So, any spare moment I had at work, I spent planning a new trip, which unfortunately had to now be solo. I travelled to the Maldives in order to film the opening sequence of Season 1, hoping that nothing could be better or more engaging as a backdrop than the candy floss skies of the Maldives. I was up all night hoping to capture the starry skies, free from the light pollution of the cities, but the clouds wouldn't allow it. The first ever take for the opening sequence of Astronomical Episode 1 was done just after 5 AM. But I wanted this to be perfect, so I redid the scene over and over again. 37 times to be exact. I had been repeating the same lines along that beachfront for 2 hours and 12 minutes before I felt that I had got the shot that I wanted. By which point, the rest of the island was now awake. It was only when I got home I realised that the first take was the best and the rest of the shots were now meaningless. This destination was the first in a long trip, but it proved to be vital because after leaving the Maldives, my confidence was sky high. I really felt like the ball was now finally rolling in terms of this documentary being made. Almost half of the footage in Season 1 was created from this one trip. Although it wasn't perfect and there were plenty of moments where the camera was out of focus or the lens was fogged up or maybe the mic wasn't properly connected, I still had achieved what I set out to do.
isn't actually instantaneous. Light is the fastest thing in the universe.
Astronomical was now finally becoming a thing. Once I returned from the trip, I knew that this was working. So I spent the rest of summer shooting and editing, but at a snail's pace.
Today is a very special day.
I knew that in order to finish this and for it to really work, I had to quit my job.
Today is my last day at the National Space Centre.
And I say that lightly because I absolutely loved and adored my job at the National Space Centre. After leaving the Space Centre, I finished off Season 1 by filming scenes in Mauritius and Dubai, trying to utilise the environment and make the documentary as engaging as I possibly could. And then, on April 26th, 2020, I released the first ever episode of Astronomical.
Which then leads us to today. 6th of June 2021. Today is the last ever episode of Astronomical. Now, for the last 2 years, Astronomical has been the main focus in my life. It's been my main purpose. But it has now come to an end. That's for a number of different reasons, but the main one being that I can't finance myself whilst making these documentaries, because I'm not exaggerating when I say that I spend almost every waking hour working on this to make it as entertaining as possible. The goal was to make something that I would watch myself, and I think I've done that. But sadly I didn't build enough of an audience to keep it going. I know sometimes you have to let these things sit for a while because eventually they will pick up, but I just don't have the time to keep working on it. But silver lining is that last month I got accepted on a teacher training program, which means I am going to become a certified teacher. Okay, so for the final moments of Astronomical, I'm going to set the camera up to record the night sky so that you can admire our universe for one last time during this series. And I just want to thank all of the people that helped me along the way, because if it weren't for some of the connections that I made, I probably wouldn't have made it past episode 3. I would have given up a long time ago, because it is a lot of work put into it. But seeing how happy and engaged certain people have been has made it all worthwhile. So, for one final time, I'm Damon Scotting. 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 And this, and this, and this, and this, and this, and this was Astronomical. There we go. We're done. What is the largest planet in our solar system? Well, when we talk about the planets, we usually split them up into two categories. You have the inner rocky planets Mercury, Venus, Earth and Mars, and then you have the gas giants, Jupiter, Saturn, Uranus and Neptune. The largest of the gas giants is the god of the planets, Jupiter. It is 142,984 kilometers in diameter. That means it's large enough to contain 1,321 Earths, making us the size of a marble compared to this. In fact, do you see that great red spot on the surface of this planet? That is Jupiter's raging storm. It's visible from here on Earth through a standard telescope, and it's likely been ongoing for more than 400 years. It is so large that the surface area of this storm could swallow our planet 3 times over. This entire storm would consume our planet with room to spare.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1.
I'm Damon Scotting, and this is Astronomical.